In inglese. In inglese. Fabrizio? Siciliano qui si potrebbe. Accomodatevi. Simone? Scusate, ci dovrebbe essere una persona collegata da remoto di Pico
Ci sono.
Simone Paoletto.
Buongiorno a tutti, mi sentite?
È collegato?
Buongiorno, mi sentite?
Perfetto, sì, vi sentiamo Simone, grazie mille.
Grazie a voi, buongiorno a tutti.
Sì, ti siedi con loro, sì. Ti do il microfono però, e dai il microfono a loro. Io me ne vado, era solo per fargli sentire.
No, ma anche io mi siedo, no?
Sì.
E ce ne andiamo tutti? Ti seguiamo?
Siamo ancora quasi minuto due, scusate che stanno cercando di far entrare.
Allora faccio io la prima domanda. Siete pronti? Allora, la domanda è seria. Chi manca seduto al tavolo, secondo voi?
Chi manca
Tutto questo tavolo. Domanda aperta al pubblico. Chi manca seduto al tavolo? Bravissima, ha vinto. Ha vinto un premio.
Il nostro 40% di donne.
Qui anche coi capelli non siamo messi benissimo, quindi come possiamo dire... Tu sei fortunato, sei fuori dal tunnel, noi invece poverini. Vai che tu.
È vero. Ancora un minuto, speriamo che qualcuno arrivi.
No, se non...
Magari Roberto all'inizio ricorda la regola di come ci siamo dati. Poi posso aiutare io a prendere domande dal pubblico se c'è tempo.
Ma faremo in modo che ci sia tempo, così almeno. Pensiamo di fare 5-6 minuti di intervento per ognuno.
Anche meno di 5,
Così lasciamo almeno una mezz'ora. L'obiettivo principale è quello alla fine, lungo inizio.
Perfetto, dai, possiamo cominciare.
Allora, buon pomeriggio.
Facciamo in inglese quello che è possibile, non si può.
Ah, sì.
Io traduco.
Io mi sembra,
Hello to everyone.
Okay, I think we can start. This is the first industry panel, and we have 6 panelists, 5 here and 1 connected. We have Fabrizio Brasca from Wintre.
Hello, hello to all.
We have Leonardo Martorana from Matic Mind. Stefano Delia from Vodafone. Luciano Lucrezia from TS. Sergio Benco from Team Telecom Italia. And I think we have connected Simone Pauletto from Picosats.
Hello everyone.
Okay, as you know, the topic here is to talk about the innovation needs and the innovation challenges that the industries propose to this audience, and that represents the Italian ecosystem of research in telecommunications. And we agreed that we will have a short presentation from each of the panelists of about 5 minutes, if less is not an issue, in order to give space to the question and answers to the rest of the panel. And I will start from the beginning to ask all of you in the audience to think about what I say, what they need, what are their main challenges, and ask questions. Because the ultimate goal of this kind of panel sessions is to facilitate the meet of offer and demand and offer of innovation. So facilitate the meet between industry and academia, or industry and bigger industry, and small, medium enterprises and academia to work together to address these kind of challenges. So I will start from the first in the list that, if I remember correctly, is
Me.
it's you, yeah, exactly.
Okay.
From
I'm
Windsor.
starting. So, thank you to all. Thank you because I'm here. I can express let me say, my opinion about the innovation and what in Win3, as I'm working in Win3, we see for the innovation at the moment of the situation in the world. The main word for us is monetization. I think it's for all of us, the main word is monetization. But monetization about what? The first one is the 5G infrastructure, because all of us, maybe the operator, are going to implement the 5G network, and it's a big investment. And so it's the time to monetize that investment. What means? There are two things that we are thinking about. One thing, it's the edge computing, for example. We discussed this morning in Grand Challenge for different level, for example, of edge computing, but also, for example, the private network. Let me say, in the past, we read a lot of article about private network, and about 2024, all the world have a private network. It's quite hard now. I read just at the end of last year in Europe we have less than 100 private networks, so it's very small number. One other things that we are working for innovation for sure is the API, the Open API, because Open API could let me say, engage also an ecosystem to provide the new services. It's not, we are in mind that not only the operator is able to do everything, maybe we need just other partner to do some new services. And the last one for sure is the artificial intelligence monetization, because now is the right time to do that. And for sure we are able to do artificial intelligence inside of the company, but we have to find out how we can provide artificial intelligence for our customer. So this is what are we meaning at the moment for innovation.
Thank you very much. I think you touched a very important point about network monetization. The market is stable, no? And so we have to unleash new kind of application that could require for new features from the network. So, please.
Good afternoon, everyone. I am Leonardo Martorana, and I am here on behalf of MaticMind. MaticMind is a system integrator in Italy, and first of all, I want to thanks all of us to invite us to this very important opportunity for us. And in particular for me, I'm very happy to be here because I come from Palermo, and fortunately, MaticMind since a few months have a new headquarters here in this beautiful city. Why we are here? I think for a company like MaticMind that is present in all Italian territory, from Milan to Palermo, and because it is involved in system integration for public sector, for private sector, and we want to innovate ourselves in order to become very important in the business of the IoT management, but also for telco business. We want to program, deploy, and of course implement a new model of machine learning and artificial intelligence that can be built a new model for energy efficiency and for resource efficiency in the network function of the important infrastructure, for example, like 5G. Because this is important. It is important because the most important energy consumptions in a network is of course for radio access network, but also 30% more or less is on the 5G core network, where we have many network infrastructure, many network functions that it can be optimized in order to optimize the efficiency and energy efficiency and resource efficiency. And this is important for the paradigm of cloud and edge computing. We have many resources that can be, of course, in the edge part of the network and other functions that can be in the cloud part of the network. How can we decide which these networks can be run, can be functions? Because we want to implement and project, design new model based on the data that can be get from the network using particular platforms, particular tools, for example, like Grafana, like Prometheus. And with these tools, we can get many of the data of performance of the consumptions, and the model can help us to decide which function can be run or can be stopped during the night, for example, during the when the throughput is more high or more less. So for us, it's important to get this challenge, and for us an opportunity to enter in a future business for the IoT and for the core network, infrastructure network, in order to improve the technological that can be will be in the future by now. So.
Thank you very much, Leonardo. Next speaker is Stefano Delia from Vodafone.
Thank you. Thank you for this invitation. I'm representing here Vodafone, and in particular Vodafone Networks. That is the part of Vodafone that has the task to design, build, operate and optimize our mobile and fixed networks at global level. Here in Italy in particular, as a part of Restart, I'm representing Vodafone Servizi and Tecnologie. That is the Italian component of Vodafone Networks. We are roughly 700 colleagues working on the design and optimization and engineering and operation of fixed and mobile networks, not only in Italy, but also abroad. Being a part of the company that is mainly involved in network design, optimization and operation, I think that when I think at innovation, what I immediately think about is every solution, every idea, every technology that can help us to do this task while maintaining our, I would say, standard level of delivery. Of course, mobile and fixed networks have to be, I would say, the first task is that they have to be of the highest possible quality. We have to, we have to be measured and considered as the best network in all the markets where we operate, in all the possible benchmark, altro consumo, OCLA. Our task is always, let's say, to be recognized as the best network in the market where we operate. But it's important also, and this is probably something that is less visible from an external point of view, it's important also that our network are efficient, that they are built following criteria of efficiency and also, I would say, to be, for instance, energy efficient, and to be efficient in terms of topology, number of sites, choice of the appropriate technology. Of course, the scale of Vodafone is helping us in this because we have the opportunity, to engineer a solution once and then to deploy this in many markets. But of course, in order to do this efficiently, it's important that we look at all the possible innovation that we have. Just to mention one, because it's something that we are working about also in Restart, automation is probably one of the key, intended as, let's say, to find a way to introduce as much as automation, as much as artificial intelligence is possible in the design and operation of the network. This is probably one of our main tasks as network engineers in these days in Vodafone. Of course, it's an optimization process, and the aim is to maintain the highest quality while minimizing cost, energy consumption, and all these related, let's say, and all the related costs. We have a slogan that is called the Zero Touch Network. Okay, we aim at, let's say, we aim at developing automation solution also within Restart that can help us to obtain this target. Of course, feel free to ask me any question after this first round.
Yeah, sure. Thank you. Thank you, Stefano. Next speaker is Luciano Lucrezia from TS.
Hello.
If you want to talk in English or
I can talk in Italian. Ok, excuse. Ok, maybe mixture. Ok, io sono TS. TS è una piccola e media azienda fondata 25 anni fa. E da circa 20 anni, i primi anni abbiamo sviluppato software. Dopodiché abbiamo fatto nostra, abbiamo sposato una frase di un programmatore che diceva che se ami il software fatti il tuo hardware, si chiamava Alan Kay, e abbiamo deciso 20 anni fa di fare dei router e abbiamo iniziato a progettare, a realizzare e a produrre router completamente in Italia. E devo dire che abbiamo avuto un discreto successo, visto che dopo 20 anni siamo ancora qui, a dispetto delle varie crisi che si sono succedute, compresa l'ultima della pandemia. I nostri prodotti sono noti in Telecom Italia, in Wind, e li usano anche in modo abbastanza massivo. La partecipazione in Restart ci rende orgogliosi perché l'abbiamo considerata come un riconoscimento di quello che abbiamo fatto in 20 anni da un lato, però dall'altro lato ci fa gioco perché ci aiuta, siccome siamo un'azienda, conosciamo bene i nostri limiti, siamo consci di quello che possiamo fare, per noi la viviamo come una sorta di fideiussione. Ci dà un po' la garanzia, la tranquillità che quello che stiamo facendo è vagliato anche in ambito accademico. Ovviamente noi non siamo la Cisco, la OneWay che ha i suoi studi di ricerca e tutto il resto, quindi ci dobbiamo appoggiare, diciamo, i nostri prodotti nascono dalle richieste dei vari clienti e soprattutto dallo stimolo di enti accademici e centri di ricerca. Per esempio in questo settore T-Lab ha fatto molto. Anzi, preferiamo, ci fa gioco che l'Accademia, nel progetto Restart siamo insieme al Politecnico di Milano e di Torino, funga da esaminatore che ci dica se alcune cose le stiamo facendo bene oppure se stiamo andando fuori strada. Credo che i risultati sono abbastanza soddisfacenti perché nell'ambito del progetto noi abbiamo realizzato un router, un semplice router, però il router qualcuno ne deve fare, quindi sembra semplice, apparentemente sembra una commodity, però c'è molta tecnologia dietro, c'è molto software. In questo progetto stiamo, a parte realizzare il router, stiamo anche cercando di capire come utilizzarlo, no? E a partire da un'idea embrionale che noi avevamo nel mondo SD-WAN, abbiamo creato un modello, anche appunto confrontandoci con il resto, dove è molto ambizioso, un modello che prevede di connettere almeno 20.000 dispositivi utilizzando software open source, quindi una soluzione cost effective, scalabile e veloce, no? E siamo a buon punto. Adesso quello che faremo i mesi a venire è perfezionare, e da qui appunto la collaborazione è ottima, i vari algoritmi di selezione del percorso. Per esempio noi abbiamo una nostra soluzione che funziona bene quando la decisione viene fatta localmente dal router, la decisione di quale strada seguire. Vorremmo lavorare in modo tale che ci sia un orchestratore centrale che sceglie che cosa deve fare il singolo router e possibilmente in base ai dati che noi gli forniamo possa fare anche predizione, analisi, insomma riesce a capire che sta per arrivare, insomma, soprattutto nell'ambito delle rete mobili noi stiamo cercando un algoritmo che riesca a capire che sì, guarda, c'è congestione, ci sarà congestione da qui ai prossimi minuti. E vabbè, questo è il quadro. Non ho altro.
Grazie. Grazie Luciano. Next speaker is from Telecom Italia, Sergio Benco. Please, Sergio.
Yeah, thank you so much for this invitation. I'm really proud to be here in front of most of the people that brought me here from an academic point of view and professional point of view. In Telecom Italia, I work in technology innovation, the mobile access program that is devoted to extend the automation, as we already heard from Vodafone, and programmability in RAN networks, in using a new paradigm that is related to the service management and orchestration solution. I already heard a lot of works related to that topic. It's very important to broaden the participation to expand relation and to the execution of the so-called Air apps, so the application that works inside the RAN intelligent controller, that is quite new way to manage the RAN. The most important thing here is to make your algorithm runnable applications and giant application that can run over the RAN that we have in field. So we are going to prepare to set up laboratory experimentation during the work we done in Super, in Spoke 4. We participate into two different spokes. So Spoke 4, that is Super, that we already heard about previously, and Spoke 5, industrial networks. In the Spoke 4, for example, the SMO is the target application or target mainly function for orchestrating RAN or radio access networks. And in the industrial networks, we are investigating also industrial Internet of Things. So in both main topics, we are also involved into standardization effort for 5G and beyond, and even 6G efforts. So it's very important to be open to you every day. So in order to collect in that kind of opportunity, as the plenary opportunity are the best kind of opportunities to collect your interest and your inquiries regarding the way to make your algorithm something that can be run into the working network. That's all from my side right now, but I'm waiting for you.
Okay, we can complete this first round with Simone that is connected. So I give you the virtual floor, Simone.
Thank you. Can you hear me?
Yes, well.
Okay. So thank you very much for the invitation. I'm sorry I couldn't attend on person. I love Sicily, I love Palermo, so I hope there will be the occasion in the future to be there with you and to network with you. Let me spend really a few words about Picosats because maybe it's not well known as the other companies participating at this panel. Picosats is a small company based in Trieste, born as a spin-off of the university in 2014. Nowadays, Picosat is focusing on the development and the provision of a telecommunication system for small satellites. We are operating in the new space economy, so we are trying to be fast in the market, low cost in the market, and also agile in the way of working. Our mission is to build low dimension miniaturized systems working at high frequency, so that gives even to small satellites the high performance that you can have working in Ka band, Ku band, and also in QV band. We have mainly two lines of products: the radio products that we call RadioSat, that involves transceivers, transponders, and software-defined radios, and BeamSat, which is our antenna lines that has patch antennas, horn antennas, double reflector antennas, and in the future beamforming antennas. Picosat now is on the new market that is developing on the satellite side. So now I can talk about what are our necessity on investments and on innovation. Picosat, as you may have understood, is really focused on hardware provision, hardware with its own software provision. So one of the key points for us is to move at higher frequencies. So we are investing in working on QV bands, so up to 50 gigahertz, where you have a lot of spectrum to occupy and to have higher performances with respect to lower bands. We are working on miniaturization, so to put high performance devices in small satellites to build constellations. And we are working on integration talking about the electronic parts, so the integrated circuits. And this is one of the key points, because here in Italy, in Europe, we are really linked to the US market for this type of circuit. So we are going to be driven by their innovation and not by what we want to build, and not what are our necessities. We are involved in the Restart project within the ITA-NTN project, Infinite Cascade Call, where we are trying to build a versatile transceiver that can be put in satellites and work with inter-satellite links, work with service link to devices, and work in feeder links with ground stations. For us, the versatility is one of another point where we want to innovate, so that the satellite in the future will be also hardware reconfigurable. So with the same transceiver, we will be able to use the satellite for 5G, 6G networks, and even beyond. This concludes my topic. Thank you.
Can you hear me? Okay, sorry. I have a consideration and a question for all the panelists. Start from a consideration. The telecom market is almost saturated in Europe, you know? And if you consider, for instance, at least in Italy, the cost of telecommunications for each individual user is something more or less around 10 euro a month. And if you compare that cost with all other utilities that we pay, like energy, water, gas, or whatever, this has improved in the last years of 2, 3, or even 4 times, as you know, especially after the war, the price for the gas and the energy increased a lot. Clearly, this limit significantly the need for the investment of network operator. One way to mobilize this sector and relaunch the telecom business is to try to monetize as much as possible the network. So my question is to network operator and to the other panelists that are companies making business at the end with network operator, with telecom providers. What do you expect from innovation in order to, let's say, unleash this network monetization, and what kind of innovation do you expect and you do want to establish with the Italian academia? I will start with the same order, with Fabrizio on my right-hand side.
Okay, thank you for the question. I'm not sure that I'm able to answer to the question because it's a very hard question. The point is, I have to check to my artificial intelligence server. So let me give me some moments. No, the point is that for sure the network monetization is one of the most important activity that we have to do. For sure, we are here also to understand with the other Restart partner to understand what we can do. What I can see in the project that we are involved in Restart, one of the things is related for sure to the edge cloud computing. Maybe it's better to say multi-access edge computing. This is a new opportunities for the telco operator because means move the technology, move the artificial intelligence, move the intelligence very close to the customer. It works very well for sure for the business-to-business market, but sometimes it also need for business-to-consumer. I think this could be a good option for the future, for the monetization. Other things for sure are the 5G network functionalities, the slicing and so on. But the point that I see is that the difficult to share with the market, with the customer, which kind of opportunity they have with the technology. This is the main point that we have. I ask to all the people here, all the people of the Restart, you are doing a very well innovation, but I see we have at least 1,000 scientific paper, more or less. Okay, more or less. The idea is that move your mind to the business model and try to understand how your innovation could go to the market. This is one issue that we have because for sure you produce a lot of innovation, but our difficulty is to do to the market with that innovation. Sometimes we are not able to understand, and if we are not able to understand the innovation, for sure the customers are not able to do that. So one point that is it's very relevant also for the monetization of the network is to disseminate the technology to the casalinga di Tortona, let me say. I don't know in English how to say, but this is the point. To share to all that information. Because another point I have in mind is just now we are all men, okay? And the innovation now is for men. The idea is that I don't see women that provide innovation for women. This could be a new revolution for the future because something is changing in the world, and so maybe we need that the woman do innovation.
Thank you. What's your opinion?
Okay, I want to talk in continuous with your speech because it's very important to monetize the research output, the research outcome. As a solution engineer in a very big company here in Italy, I'm sure that without research, without innovation, we cannot follow the world. The world is changing every time, everywhere. So we have to really to follow this changing. what we are doing, we are trying to do in our company is to innovate our position in the market, because it's very important to think about many other new models using the new technology that that is in this time, like machine learning, like artificial intelligence. Those are not simple an idea or fantastic things that we can imagine in a movie, but it is part of a real time now. We contain machine learning in our smartphone. We see the effect of artificial intelligence in every day in our day by day work. Okay, so I think if we put the research outcome, our skills, and the innovation coming from women, coming from the young people of the university. We are in this moment in the center of the knowledge, of the new knowledge in the world. I think we can find correct solution in order to improve and optimize the usage of the resource, for example, in 5G networks. I think if we put in the field these solutions, we can improve, of course, the quality of service, but also we can respond to the increasing of the price. We can respond positively, and with the knowledge, with the research, and with the science, to worse, to whatever you want that put the world in a bad side. We have to change. We have to put the world in the positive part of the future, of the history, and of course the science and the research. Thinking, of course, to monetize the result is a part of our mission, and it's not a joke, according to me. It's not a joke, because every day we see the price increase, and we need more solution. And we have the instruments, the tools that can help us to change everything in our world. So this is my opinion.
Thank you. Stefano.
Thank you. I agree with Fabrizio. It is a very difficult question to answer, to address. I agree also with his first point, that is, let's say, to think not only at innovation in the area of network technology, but to think at a wider spread of innovation that could reflect and could be positive for the network or for the increased usage of the network. I'm thinking also at some, I would say, historic example, such as for the advent of the smartphone. The developments were probably on technologies such as the touch screen or the batteries that were not strictly related to telecommunication, but at the end they were probably the main enabler for the development of 4G. So if I think at, let's say, historical example, my question is, don't focus only on the innovation in the area of network, of technology, of course, of telecommunication, I'll say. Of course, this is very important. It is my, 99% of my daily work. But think also at other technology and other solutions that could be relevant. The other point that I would like to, let's say, to mention, perhaps to complement this, is also to think at different ways and different, I would say, usage that we can do with the existing network. Probably this is something also that we have not been good as network operator to communicate in the past. But what I've seen in my experience is also there are many functions, many aspects of, let's say, of the networks today that are probably less well known, I would say, to a general population, perhaps even to the, I would say, to the academy, that could be very, very important. I have in mind one example that I was thinking about when I was looking at the poster this morning, which by the way, were very, very good and very interesting. I've seen that as a Restart, we have done a lot of pilots and publication and work with LoRaWAN, that is a mobile IoT technology. I was thinking, we have mobile IoT networks deployed and working in Italy, such as narrowband IoT or CATM, and perhaps we have not been able, to, I would say, I use a bad word, advertise them, or let's say, to make them more well-known, I would say, to all the stakeholders, even within the academy. They are used because it's likely that perhaps you don't know, but for instance, in the gas metering market, probably, I would say, 70 or 80% of your gas meters now have an embedded narrowband IoT SIM, given, I would say, also thanks to the work that we have done together with the academy and with the regulation authority. But this is just an example. There are some aspects, some part of the mobile network, for instance. Sorry, I'm mentioning the mobile because this is what I work on, but there are some part of the telecommunication network that probably we have to think about altogether how we can use and how we can exploit at the end to give a service to the country, let's say, to give a service to the society.
Thank you very much, Stefano, for your consideration.
Vado in italiano, dai.
Sì.
Allora, cosa ci serve? Prima di tutto ci servono buoni ingegneri. Io su questo devo rubare un concetto che avevo sentito da Nicola, che faceva un paragone con l'industria del nucleare, che una volta ti avevo sentito dire che in Italia negli anni '80 si sfornavano migliaia di ingegneri nucleari, adesso sono pochissimi. Noi abbiamo vissuto questa cosa, nel senso che quando abbiamo iniziato questo lavoro, che è veramente altamente tecnologico, abbiamo reclutato un po' di persone, più o meno un po' di cariatidi come me, perché venivamo da un'azienda che faceva ricerca e sviluppo e sono là. Ci manca la generazione intermedia. Adesso abbiamo degli ottimi ingegneri che sono i trentenni, 35enni, che stiamo reclutando dai vari politecnici. Ci manca quella intermedia, quelli che si sono laureati quando c'era il boom della net economy, negli anni 2000, quando in Italia era difficile che io trovare una persona che ne so, che usasse l'oscilloscopio oppure che conoscesse il kernel Linux, la routine di interrupt. Eravamo molto sbilanciati sulla parte applicativa. Per carità è un mestiere nobile, però noi che abbiamo la presunzione di fare telecomunicazioni cercavamo qualcosa più a basso livello. Però vedo che la direzione è giusta. Cioè, qualcuno del Politecnico ci ha mandato dei ragazzi che sono bravissimi, sono inseriti nel giro di pochissime settimane. Da un punto di vista accademico, noi cerchiamo, non voglio tirare in mezzo AI e cose, non ci credo a queste cose, no? Noi cerchiamo degli algoritmi che facciano, che date una mole di dati, e dati noi ne movimentiamo parecchi, il collega citava Grafana, noi tutti i nostri dati li mettiamo sotto Grafana, quindi di un router sappiamo tutto, vita, morte e miracoli, quando va giù, quando va su, il round trip e tutto il resto. Stiamo cercando un algoritmo in grado di fare network prediction, prevede che ci sarà una congestione e di conseguenza poi prendiamo azioni correttive, qualcosa che sia affidabile. Più o meno la direzione c'è, non lo so se ci riusciamo. E il terzo punto è quello di avere degli algoritmi che siano in grado di fare network performance e traffic shaping in modo efficace, non con dei server super costosi, perché dall'altro lato abbiamo in mente anche il discorso del risparmio energetico, no? Quindi io so benissimo che se prendo una macchina Intel, supermarket e tutto il resto faccio quello che voglio, però a noi ci interessano soluzioni, magari FPGA, quello che è, innanzitutto devono essere abbastanza cost effective, efficaci, sia per le prestazioni sia per la qualità del servizio, la QoS, no? E non banale queste cose qua, quindi perché per le reti non basta trasmettere i dati, bisogna trasmettere anche in un certo modo. Questo penso che sia abbastanza.
Grazie Luciano.
Grazie Luciano.
Sergio.
In team technology innovation, we think that we could mobilize this industry in two different ways. For example, we can save money. One way to make money is to save them. So I think it's better to have an effective and optimized RAN or radio access network, because it accounts for half of the operational expenditures, so OPEX. And we would like to ask for help to you, that you are our opportunity to make an effective and optimized radio access network make real. And this is the first strategy that we would like to pursue, even using the service management and orchestration function that I mentioned before. But in order to let you have an active role to make that real. For example, if any of the interesting work that you described before and tomorrow will become an application for a RAN management platform such as this SMO, I think we could have a lot of margin of saving money that we actually spend doing things manually. So the automation is a very important topic to make real. Another kind of strategy could come from using the API monetization. We have to open up all the internal function towards the B2B clients. For example, we could extend the programmability of our RAN in cases of where we have standalone deployment, for example. So in a B2B application, we could offer the opportunity to you, to any spin-off that could come in that field, to offer a specific application tailored to our customer needs. This is a new economy, this is a new opportunity, business opportunity. An entire new business model could born in order to, I think, mobilize the economy around telco. Thank you.
Thank you so much, Sergio. Simone, the last in this round.
Okay. Also for me, this is quite sorry, I hear a lot of echo. Okay. No, okay, maybe now it's better. Also for me, this is quite a difficult question, even because in the space industry, new space economy, the monetization is quite a hot topic. And what we can ask to the academic and on the research side is maybe trying to replicate the move that the market is doing from government, from defense, government and agencies to the customers. Maybe even on the research side, we need to try to think about what the new feature, what we want to do for the customer to move the space market, the space resource, even for consumers. And this is really linked to 5G, really linked to 6G. And I'm very happy to be participating in Restart, which is trying to do something like this. And on this topic, I can see that we see a lot of research, very good research, but at low TRL, technology readiness level, trying to extend the research at higher technology readiness level could speed up the process to innovate, even on the business side, so even for companies, and trying to save money to monetize more, as my colleague was saying before. And so this is one of the important topic. And I will conclude by saying that at the end, when we will be offering a service using satellite to consumers, of course, the end customer will go where the price is lower. So this is very, very important. But maybe a challenge is that if we offer more services, more features, something more than what is offering our competitors, we can have also higher prices. So another challenge that I can launch here is to trying to see more features that we can have with 5G, 6G networks using satellites, including the satellite networks, to include in our service, and to have higher prices and higher benefits for customers. Trying to think about maybe business to business, giving internet to ships, airplanes, not only user equipment and the users or stuff like that. Thank you.
Thank you, Simone. There is time for questions for the audience now. So I would really be happy if there would be some kind of debate with the audience. Any question? Yes, please.
I can ask you, I don't know if you can hear me. Considering that you only have 7 minutes to answer to my question.
The answer is no.
Actually, this was stimulated by your answer to the Roberto's question. I don't know if you agree with me, but you may say that there is some defensive innovation. We should try to save costs without really generating new value, or innovation that generate new value and new revenues. In the end, right, if you automate a network, you are just saving costs, but you are not getting more money from new customers for new services, right? So what make the difference between innovation that create new value and innovation which is just a way of cutting costs?
Roberto, it's for you. No, the question is for you.
No, it's not for... I don't, you want my answer, I can answer, but I prefer the other. No, I can answer. I believe that, for instance, it is true that with network automation, you can, in general, with the massive use of machine learning and artificial intelligence, you can save cost. But at the same time, you can allow the network to automatically react to something that is, for instance, a request from an enterprise customer that they want some kind of new feature, a new, let's say in an old-fashioned way, a new VPN with given SLA characteristics, and in a very, very fast go-to market. That means automatically they ask something and they can pay for that service. So network automation and machine learning, artificial intelligence is not only a way to save cost, in my opinion, but also a way to unleash the, not only enterprise, even person, but let's talk about enterprise, because I think that we really need that enterprise want to make the true digitalization of the industries and so on. And in that case, you enable something that now, even for the very long time to establish the new service and so on, simply don't happen. So this is at least my point of view, but now...
there is only one point. Find out the killer application. I'm looking for the killer application since 1999, and maybe I will be retired without find out the killer application. So, but I hope, I work every day to understand what we can do about that. I'm agree. It depends on the time. Maybe now we are in a situation where we have an approach more tactical. We have to try to reduce our cost. The operator try to reduce the cost because it's the only chance that we have now to survive. Yes. But I hope, and this is, I hope for me, because otherwise I have to stay at home tomorrow because the company don't want to pay me. For sure, the innovation is the more strategic to do. And the point, as I said, try to find out the killer application. Maybe someone will find the killer application. And we are not able to do. I remember the OTT and also the other partner, now Musk, try to use the satellite to versus the 5G network and so on. So it's not a good point for us, but anyway, we have to do something to go in the future.
Google, Facebook, WhatsApp, they knew how to use the network, so we should learn from this. I would start from Sergio, that is the microphone close to him.
Thank you for the question, Antonio. I appreciate a lot that this is a hot topic. So there are main strategies to face that. I recognize that to scale around economics or around the saving money concept is too stringent for the academia. I understand. But in that period, when an incumbent came from the space, as you know, we have to make our work as best as we can. So we have to perform much better than those incumbents. So this is the round in which the best that we can gather from the new technology must be shown, must be on the hand of the customers. And this is not yet done. Think about the enhanced mobile broadband, only way of using the current networks. We have to expand towards 6G kind of generation networks, and we have to offer a new broad set of services to our customers in order to pay for them. If we think about the traditional customer that is interested only in broadband communication, we are saturated that market. So we have to find out a new way, a new business model to reach the new customers that are waiting for us.
Okay, coming back from Luciano.
È una domanda, non so rispondere. È come se tu avessi chiesto: sono le idee che influenzano la società o la società che forma le idee? È difficile. Sono abbastanza d'accordo con colleghi di Wind. Potrebbe esserci la killer application che ti stravolge tutto, no? Abbiamo visto, soprattutto nel settore delle telecomunicazioni, invenzioni, standard, brevetti riesumati dopo, messi lì, accantonati, riesumati dopo 20 anni, 30 anni. Per esempio Internet ha dato lustro alla ISDN, non SDN, che era una tecnologia degli anni 60. Poi è uscito Internet e hanno recuperato queste borchie qua, dopo 20 anni. No? Quando c'è stata la pandemia, per fortuna è durato, però c'è stato un revival magari di componenti che erano considerati obsoleti, inutili, cose li abbiamo recuperati perché serviva. Quindi non lo so, è difficile. Non me la sento di rispondere.
Stefano, da te vogliamo una risposta forte.
Okay, I will do my best. I like the idea of separating or classifying innovation as defensive and offensive, as we say. Just let's say a thought about it. I think that some innovation that for us are probably seen as offensive. I'm coming back to the example of IoT networks. IoT networks, from a network perspective, are probably offensive because we are gaining a new market where we were not there. From a gas metering company, this is defensive because at the end it is a new mean that they have in order to save the cost of the guy that have to go and read the meter. Also looking at the automation, I would say we should think also about I would say, especially if we are able to build an open innovation concept and not something that is, only related to verticals, to traditional vendors, to traditional technology providers. There is also the possibility to enable a new market where the development of algorithms, the development of open solution could be really, I would say, revamping, the telecommunication market.
Thank you.
Tutto quello che uno fa per passione non viene mai smarrito, no? Per cui esortiamo a fare le cose, farle bene. Poi dopo ci sono gli eventi che decidono per i giovani.
briefly, I think it's a very good question, very difficult to respond, but we have to try every day to get balance between cost saving and investment. And it's very difficult for us. But I think the customer is the point of view of the research. I mean, if the customer have needs, like we talked about before, the research can find the solution. And of course, to try to find a solution, we have to invest. So we have the best response. I don't know, but the market is moving from the customer, and the customer have needs, and we have to solve its needs.
Thank you so much. We can conclude with Simone.
Okay, thank you for the opportunity to answer also this question. I think on my side, there's no need to differentiate from defensive innovation, let me say offensive innovation, on the satellite market, on the telecommunication satellite market that is going to be the future. There's only need to offensive innovation. The architecture is still to be considered, the infrastructure is still to be built, so we can have space for innovate in a more efficient way as we can, and in a more sustainable way as we can. So this is my point.
Thank you, and I think we can conclude now this session. Thank you all the speakers and the audience for participating.
Thank you, Roberto.
Thank you.
I think it's the first time that we have a question from the public, and the answer is for the chairman. It's innovation. Yeah, you are innovation.
Thank you. So, very well. So now we continue with the technical program. So there will be a series of technical sessions chaired by different chairpersons. The first chairperson is Marco Dalai. Where is Marco? Marco? Okay, so I will be the chair of this session. Okay, so the first speaker... The first session, technical session, is on experimental facilities, and the first speaker is Marcello Caleffi, University of Naples, Federico II. Quindi Caleffi, le slide, grazie. Ciao Marcello, benvenuto. Ciao. Please go ahead. Can you put it in full screen? Yes. Okay, take the other one.
Okay, apologies for my voice. I'm Marcello Caleffi, and I'm here to share with you the ongoing experimental activities that we are conducting in Naples toward the realization of a quantum internet testbed. So this is the people behind this activity. This team I co-lead with my colleague Angela Sara Cacciapuoti, and as you can see from the color, the team is quite interdisciplinary. We have engineers as usual, but we also have physicists. This is quite common for research group working in the quantum domain. During our quantum journey, we start with activities that were related to the design of the quantum equivalent of the TCP/IP protocol stack. And this is the main activities. And since the beginning, we address these activities with a top-down approach. This is quite common in the telecommunication engineers community, and especially when it comes to network protocol design. And this is the prototypal example, RFC, request for comments, published by the Internet Research Task Force within the Internet Engineering Task Force. And this is not an implementation RFC, it's an informational RFC. where you have a top-down approach trying to abstract from the particulars of the underlying technology for designing protocols. And it's quite common, and indeed there was an analog RFC 9058 back in 96. What's the problem with top-bottom design? And I think these are old slides, but never mind. The issue with top-bottom design is that your design is as good as your assumptions. Everything will go smooth from your assumptions, but sooner or later, hopefully sooner, you need a reality check. Was a big issue I would say 20 years ago when we moved from wired network to wireless networks. And some of you may remember that at the beginning we were using hop count as routing metric. And then we had some experimental papers saying that's wrong. So we try to, remembering this lesson, we try to insert an additional activity, bottom up, an experiment. And we want this experiment to be run in-house in Naples. Why? Because we want to check our assumptions, and because most of you know how difficult it is to interact with people from different research domains. And at the beginning was a side activity. Okay, we will have a side activity, we will not spend so much money, so much time, and well, at the end was a mess. Before going in the testbed, let me clarify a misconception. So, what is a quantum network? Classical network is a network that allows you to transmit bits. Quantum network is a real quantum network only if allows you to transmit a specific class of qubits, which are the entangled qubits. Why I'm making this point? Because there is this misconception that QKD are quantum networks. Well, most of the QKD systems, the one outside the purple line, so the commercial QKD systems, are not quantum networks. They are classical networks where you don't use entanglement, you rather use superposition and measurement principle, and you have a classical network where just the layer, the encryption layer, can we call 4.5 layer, is quantum. And the issue with this system is that, well, they are fine because they are cheap, they are easy to implement, they are plug and play nowadays. You can buy a full setup for, oh, sorry, that was, no, that's not me. You can buy a full setup for 100K, but the issue is that there is no entanglement. And if there is no entanglement, there is no advantage with respect to classical solution. Shor algorithm is so efficient in factorizing integer because it exploits entanglement. That's the reason for having a polynomial complexity. Can someone help me with the Zoom? Okay. So we decide from the beginning to build a quantum network. And we decide to have 3 requirements. The source should be compact. In the picture, you can see, this is not the source. This is just the channel encoder and decoder of one of our experiments for the PNRM project. The source is not shown for intellectual property. As you can see, well, you cannot, even if you don't see the source, you can guess that the source was not compact. The source was using a bunch of space, was on the optical table for avoiding vibrations, and the setup was very long, something in the order of weeks. The other problem with that experiment was that the wavelength of the photons were visible, 800 nanometers, which is good because the sources are cheap, but it's bad when you want to transmit entanglement far away. But it was cheap. 300K, you can buy everything you need. And it was attractive because the entanglement carrier, the equivalent of information carrier, was something that we can manipulate. So we spent a couple of years trying to find out a producer which was able to build a source with these 3 requirements. And there are still no sources of this way on the market, and we spent 2 years trying to understand with different producers, can you do it or not? And well, we succeed. This is, on the right you have the source, the black one. And as you can see, the whole source is in a racket size. It's 4 or 6 U, but still fine. And the whole electronic needed for controlling the source, the gray box on the left, is racket size as well. And the fibers that we are using are very cheap, normal, monomodal fibers that you can find almost everywhere. So we succeed in addressing these 3 requirements. And again, perfect. So as you can see, we had these 2 long time step, understanding the requirements, discussing with producer, and now, well, now we are almost ready for our fiber network. Lesson learned is that the budget, you should double your budget, but 4 times doesn't hurt. And when it comes to time, there is this law which is quite popular among software engineers, which is a recursive law. And the beautiful of this recursive law is that it gives you a fine tuning about your time. Okay, so this is our test bed. We have 3 nodes. The test is metropolitan scale. The longer fiber is more than 10 kilometers. And we are ongoing in the activity of sending these photons together with classical traffic. So these are not dark fiber. These are lit fiber of our campus, and we are trying to understand how much the coexistence with the classical traffic is making everything a mess. Now what? Well, we know that there are different groups that are trying to understand the quantum domain, and they may not be interested in investing so much money and so much time in having a testbed, but we have. So the idea and the reason for which I'm here is to have this testbed as an open testbed. Every researcher can ask to access to this testbed as long as it deals, their activities deals with quantum network, quantum protocols, our area. And together we may try to push the TRL of this technology, which will be 4 by the end of the project, up to 6. So we think that we should have 2 different audiences. One is academia and research centers for doing research and deployment. We have some activities where there exists already ongoing collaborations. These were the activities fundamental for the starting of the project. So FPGA for classical signal synchronization, multiplexing, of course, standard and network protocols. But we think that there are domains which are far from, or at least outside of our area of expertise, software, controlling, electronic, where, well, people can be interested in testing their solution with a reality check with the testbed. And this is the section of the right, so academia. Academia is not the only target, the only stakeholder for quantum. And we think that companies, especially telco companies, may be interested in assessing the compatibility of their solution with quantum traffic. And last, use case exploration and validation. Engineers are not good in finding market, killer applications. We are not good for that. We cannot improvise and finding a way to commercialize our solution. What we can do is we can provide access to companies, to our expertise. So this is the main idea, and we plan to have, it's not going. Next slide, please. Almost going. Okay, so once the 6th step will be completed, we plan to have this call for expression of interest within the Restart community, asking everyone which may be interested in these activities to join us in this common effort. And I think that this is my last slide. Next one, so I'm sure. Okay, done. I think in the time, right? Yeah.
We have time for 1 or 2 questions from the audience. Anyone? Yes.
not quantum computers. The endpoint will be detectors of the photons. Only detectors. Quantum computers require frequency transduction, which is not yet, no.
Not yet. Other questions, curiosities? You said that you, as researchers, we are not good in finding applications, but actually, in this case, we should figure out, right? How do you see, I mean, for example, for quantum computing, at least, you know, an evolution path is clear. People are investing. They already have problems that can be solved better with quantum computers. What about quantum internet? What's the difference? How can we push in the direction of, you know, spending money for developing a technology? Why it should be better than using traditional technology?
Okay. Let me articulate in 2 steps. Negative answer. When Kleinrock was doing his papers about hierarchical routing, he was saying that there will be hundreds of thousands of nodes connected to the internet without no application. So classical internet has been built without having the border, the issue of finding applications. So we should keep this way. I mean, the application will come in 40 years. This was happening in the internet. We should not push companies to believe that they can make money out of this technology in a couple of years. This won't happen. But now the positive. When it comes to quantum computing, you have the physical constraints that you cannot put so much qubits in a single chip. You have a bunch of problems, the coherence, the refrigerator, whatever. How did we solve in the classical network? We don't have a single processor that have so much power. We tried to implement first, it was multi-computer, then distributed. So even companies, if you look Amazon, for example, Amazon has a center for quantum networks. And the reason is that Amazon says in their announcement that the only way to scale quantum computing up a level which can provide useful applications is by interconnecting single chips.
Well, this is a very good answer. I mean, this is a very good application. If you need to have many small quantum computers, then you need to have a quantum network for interconnecting them. Okay, thanks. Very well. So the next speaker is Diego Spinoza, University of Padua. Diego. We still have problems with PDF, but we will figure out.
So, welcome everyone. I'm Spinoza Diego from the University of Padua. I'm here to present the product of our research and innovation. That is the development of the first made in Italy, software-defined, low-cost, low-power, highly customizable acoustic modem for underwater telecommunications. I think one could say is, in the market nowadays there are several of these modems already available for purchase, but several of these solutions present some problems. Can I have the next one?
No, you can use this one and then see if it doesn't work. Okay, yes. More or less.
Okay.
Go ahead.
Okay. So, I was talking about the current context. Most of the modems we already find in commerce have some features that, some 3 common points. The first one, these devices are high power usage because they use high power to transmit long distances and then may not be suitable for all applications, for example, battery powered ones. Another feature a lot of devices have in common is the poor customizability. These devices are closed source in both the hardware and the software. And that is a problem for many applications, especially research. As a third point, we need to cite the high retail price. These devices cost often more than $10,000, which is an obstacle for many developments of such devices. And so these points restrict the usage of these commercially available applications. only to certain contexts, such as the military, the oil and gas, but it's a problem for some other scenarios. For example, we can cite swarm coordination, pollution detection, diver coordination, ropeless fish traps, which are 4 examples of application in which we have a high number of nodes, and so they shouldn't be expensive, otherwise the total setup is prohibitive. And these are all battery powered and the nodes are not placed very distant one from another. So we do not need high power transmission, and we need all of these nodes to be battery powered. So this further requires for another device. And another big application is the research purposes that calls for a device to be customizable in every aspect. And so, starting from these motivations, also for the pollution detection, which is the environmental monitoring part, is what really is inside of the Aquasmart project, which we developed alongside with the University of Catania and University of Rome Sapienza. I remind the goal of this project, that is the design of a sustainable and affordable integrated above water and underwater sensor network infrastructure for monitoring coastal environments and studying climate changes and biodiversity. A probable setup you might see is the one that is depicted on the picture, in which we have a series of underground nodes that just communicate from above ground nodes. So these must be, again, battery powered, and yeah, so they call once again for a different device that we have tried to reproduce. So our proof of concept needs to follow these guidelines. First of all, it needs to be developed as a software-defined modem. That means that the amount of specific hardware is reduced to the maximum. All the signal processing is done at the software level, so to ensure maximum flexibility and modularity. As a second point, we want to use commercial off-the-shelf hardware, if possible, so that the modem is low cost and is widely supported by the community, widely known, so that it can be customized to the needs. And third of all, once again, low power consumption, for the reasons I already mentioned. And so, what we came up with is the first modem prototype. As you can see for the schematic, we have 2 different, let's say, paths for the outgoing and incoming signal. The outgoing signal comes from a processing unit, which in the first try, this first try, was a Raspberry Pi board. And then the signal goes through a DAC, an amplifier, and a projector. While for receiving the signal, we have another transducer, that is a hydrophone, which feeds a preamplifier, an ADC, and the processing unit. And the picture depicts the first attempt of building such a modem. As you can see, it's quite mature. And so we can just spot some points for improvement. First of all, the design is loose, unstable, and cumbersome from the hardware side. But most importantly, it also has a very inefficient general purpose audio amplifier, which is against the power consumption requirements that we need to follow. But the most important is that we need 2 separate transducers, one to transmit and one to receive data. This is a major obstacle if we are looking at low-cost deployment, because if we look to make a low-cost modem, we cannot do anyway a low-cost setup, because also the transducers frequently are very expensive. And so it was time for a major project revision. And so this is how the SUM modem was born. This is the current revision of the project. And as you can see, the schematic is slightly different. We have an important detail, that is the transmission reception switch. So now what we have is a single transducer working both ways, both for reception and transmission. And so what we have come up with is also signal-related improvements. So now we have an efficient audio amplifier, which allows communication up to 70 kilohertz. So it allows us to communicate with different, in different bands in the underwater spectrum, acoustic spectrum. And the modem now also has a new form factor as a Raspberry Pi head, so it's very compact and also usable for many embedded applications. This modem now supports any transducer, both a mature and more important transducers, as we will see in the tests later. And there's also support for diverse modulation techniques, which allows us to vary with the flexibility that we need in different contexts. And there's also a networking support now from the software side, so which we may come to have multi-device networks, as we had seen before. And so, where all of this news opens to new usage possibilities, because this is not only to be used as a standard modem, to be used in even as a part of a multi-hop network, but this is an analog front-end for underwater channel sounding and characterization, because on the basis of this all, there's a Raspberry Pi board that the user can access and do whatever he wants. So this is perfect for all of the research usages. It can be used as a very low-cost device for low-cost deployments, given that we may use low-cost transducers, as we will see also later. And also a role for ranging purposes. Something that we are working on is one-way travel time ranging. So ranging just from the one-time communication, not the classical runtime tip. But now we have seen everything is good, but does it work? And that is why we needed some performance tests. What we see on the images is our team, and you can see that we tested the modem in several contexts. We can see one, which was carried out a test in the Bacchiglione Canal near Padua. We're talking about a length of 1.60 kilometers using an Aquarian transducer working at high frequency and transmitting at a power of 155 decibels. What we can see from this setup is that up to 800 kilometers, the transmission was basically error-free. And this is a great result, given that we were also working in sort of a unfavorable environment. And we also have another test that lets us see how the modem performs with a different kind of transducers. What you see on the right, the picture depicts the two different transducers that we used, respectively a Lubel that operates at low frequencies and a BTEC that operates at medium frequencies. And these tests were carried out in the La Spezia Gulf with a length, a distance between the nodes up to 2.90 kilometers, transmitting at a higher power of 100 decibels. So obviously the distance is great. What we can see is that we have perfect transmission up to 2.90 kilometers, which is the limit that we could physically go. So basically this tells us the modem has great possibility even to go further. And so, after these great results, the main remaining obstacles for low-cost deployments is the transducers that are still quite expensive. And so what we want to do is the in-house transducer production. As you can see from the image, the rightmost one, we tried to do one in-house, and that's the result. What we have from the performance point of view is that transmission-wise, these transducers we made even perform better than the commercially available ones at a fraction of the cost. And so this working at 40 kilohertz, which is the band we usually operate into. So this really opens up new possibilities for production. And so, as a last thing, after all of the innovation and this product that we produced in the university, we want to make it available to the general public. And so what we have done is that the project was developed at the university in close partnership with Subsipulse, which is a spin-off company of the University of Padua. And the company is now aiding the university in spreading all of the innovation that we have produced by making it available to the general public. And that is how the modem is now openly available for purchase. No, otherwise I will go against the targets of this project. Well, it doesn't work anymore, so I guess.
Yes.
Thanks for your attention.
Very interesting. Time for some questions from the audience. Yes, one here.
Thanks for your presentation, very interesting. You showed results using Janus modulation. Do you have any results with OFDM?
OFDM is the latest to be introduced in the software part of the modem. So it still has to go undergo precise testing as we have done. Now we're doing just laboratory tests, but it still has to be refined and released. So that is supported, but still have to have results like this.
Thanks. Other questions? I have one on very general, right? At the beginning you mentioned, these kind of things were so far being only developed for military or these kind of applications, right? This is exactly what happened for space economy, right? So can we say this is kind of a new water economy, which is for a broader set of applications, and in that case, with satellite, we know very well is going to pay for that. What about the application for underwater communications?
Well, essentially what I can say is that what we are providing is the tools, and what we can make is make the tools affordable. Then it will be for the customers and their creativity to complete the picture.
Same answer like Marcello, right? I mean, it's very difficult to get an answer on this from people. I mean, if you have a startup, you should think about the market, right?
Well, for example, as I displayed right? in the first part, we have some potential aspects in which this can be applied.
Of course.
But we don't want to limit to that.
Yes. Okay. Okay. Good. Other questions? No? Okay. So let's thank Diego. Thank you. The last speaker for this session is Giulio Campagnaro. Anritsu is coming. Great. Campagnaro, slides. Great. Okay, great. Giulio, the floor is yours.
So hello, good afternoon to all of you. My name is Giulio Campagnaro, and I'm part of Anritsu Engineering Technology Organization. As Anritsu, we are a test and measurement company specialized more on RF and microwave. So it's not low frequency, and this time is high frequency measurements. And in Italy, we are located near Rome, and we cover, of course, all the country. Today, indeed, the idea is showing you the results of a nice example of collaboration between Anritsu as a measurement company and University of Rome Tor Vergata. And we will deal with SWIPTRON. It is a remote spectrum monitoring architecture based on software microservices. And the collaboration has been established with Professor Luca Chiaraviglio and all his team that I want to thank in advance for giving me the opportunity and also helping in preparing the material you are going to see. So we will start briefly with Anritsu as its company profile, and then we move a bit deeper into the SWIPTRON spectrum monitoring architecture. And finally, we will go to see also beyond the current limitation of the system, what's their future development, both in Italy and in Europe in this moment. And finally, the question and answer session. We will also have the possibility, of course, to have specialists from Tor Vergata University in case you have some specific question on technical need regarding this architecture. So what about Anritsu? Anritsu is headquartered in Japan, but whose presence is spreading worldwide. We have a good coverage of the EMEA region, and particularly Europe, where our main focus is the wireless communication market, and also, as you have seen before, RF and microwave test and measurements. So here the idea is that within our broad catalog of both general purpose instrumentation and customized solution, I've identified really a niche of this market. It's remote spectrum monitoring. Because for monitoring RF and microwave spectra, you normally use a well-known instrument, a spectrum analyzer, who is very trustful, whose technical specifications are normally excellent, especially in terms of dynamics and dynamic range, but probably its form factor is problematic for being easily deployed outdoor. It's probably too heavy, too big for being really used, especially in a harsh scenario where you might have rain, dust. So as Anritsu, we really re-engineer the form factor only of some spectrum analyzer of ours for offering a couple of different generations of what we really call remote spectrum monitoring devices. The first one will be discussed as a future development in the Swiptron, whereas I think is worthwhile now introducing you to our second generation spectrum analyzer, because this will be really one possible implementation of a Swiptron hardware radio frequency front-end, so the way we capture signal outdoor. The maximum frequency is up to microwave, 54 gigahertz. It's easy to, you can program, really customize by using skippy command, either through Ethernet connection or Wi-Fi, but also its graphical user interface might be useful for some people. You can directly import the antenna factor you are using for calculating data directly in terms of field strength exposure, like dBm over square meter, or linearly as volt over meter. It's a sort of time-saving feature, but this is not the unique feature of these instruments. So these are quantitative measurement field strength, but we are able to offer also qualitative analysis of electromagnetic waveform, means capturing the IQ data, means checking the constellation diagram, other figure of merit like error vector magnitude against a certain standard. And this is possible up to 100 megahertz of analysis bandwidth, and with upcoming firmware release, it's a live instrument, even up to 150. Attached there some documentation you might find useful. But this is not the unique possible implementation as a hardware front end for acquiring data in Swiptron. We have another instrument that has been included into this architecture. It's called Ultra Portable Spectrum Analyzer. So it's a spectrum analyzer, but its form factor, it's really tailoring remote spectrum monitoring, for instance. There, it's implementing a Anritsu patent nonlinear transmission light technology, which actually means replacing almost entirely the microwave front end of the spectrum analyzer with a small size and high dynamic range microwave sampler. With that, we can go up to 170 gigahertz, so even millimeter wave analysis, but for sake of implementation in Swiptron, we will lose the 32 gigahertz version of this instrument. So now that we have already seen the possible implementation of the front end, we now put everything together and see the overall architecture. And of course, once more, credits go to University of Tor Vergata and Professor Luca Chiaraviglio for having implementing this particularly. Which is the context behind the need really of a new spectrum monitoring solution? Well, the point is that the wireless service, the number of them is increasing day by day. So the RF spectrum is so congested that it's really mandatory to measure carefully the radio frequency electromagnetic fields, especially their field strengths. This is of interest not only of academia, but also national regulation agency, because you want to relate that numbers with human exposure. So what's the effect of the RF waves into the human body? But this is also the limitation of current implementation of spectrum monitoring. They normally offer this kind of measurement, field strength. It means quantitative data. There is a few solutions going beyond this limit, and that's why Swiptron come to play a role. You want to offer something new, also qualitative data, so also the possibility to capture IQ data and doing time domain analysis. So since its concept, the Swiptron is defining a large-scale monitoring network, and it's adding a key feature like flexibility. Flexibility is more, let's say, both in terms of coverage area, but also regarding frequency band analysis. You can choose to analyze either pre-5G or 5G network services, and in the same way, this is very important, all the data are safely stored into a remote server location. So data is the goal, no, of this new era of innovation. And we want, of course, university is an academic institution, make these data available for enabling further PhD studies or new master thesis works. So this has been thought since the concept of the project. And here below, in the block diagram, you might easily identify the difference between the RF front end, which is provided with at least 2 different implementations of our spectral analyzer Zenritsu, and relative antenna, either provided by us or by our trust partners, and the software backend architecture, which has been developed by the University of Tor Vergata. Now, few more words on the hardware RF front end. As I said, Sweeptron is a flexible architecture, and flexible also in terms of the hardware which has been implemented there. You can choose between 2 different nodes. One is the so-called rack node, so you see the form factor is different from a bulky spectrum analyzer. Maximum frequency is 43.5 gigahertz, so targeting also 5G FR2. Field strength measurement and IQ capture are offered, so you can choose between quantity and quality of your analysis. But then there is another node called ultra portable, and as its name implies, is based on the ultra portable spectrum analyzer, is a bit simpler, 32 gigahertz, and targeting the field strength quantitative measurement. So now the point is, how can we query and retrieving the measurement data from the hardware front end and then save into the remote server location? And this is the work done by the university. So really great work, because they implement a modular software architecture. We can think about that as a one single application, which is composed of 4 different microservices. First of all, we have the sensing microservices, which is doing the most important job, is retrieving data from the measuring hardware. But then this data can be further analyzed. We can change the format. And this is done by implementing the processing microservice, the second one. Once data are ready, they are moved into the remote server location in a secure manner, and this is done by the third microservice, the transfer. And then we have the watchdog, the last one, which is very important because it's somehow managing the error queue. It's assuring another key feature of Sweeptron after flexibility, reliability. So this means that we can run the sensing microservice 24 hours a day for 7 days a week. So very reliable. And if you can do that, then you can leverage on the full flexibility of the sensing service. Its core block is actually a configuration file where it's very easy and intuitive changing parameter, analysis bandwidth, and even possibility of choosing between field strength measurement or IQ data capture. In the next slide here, we see some example of this is implemented. If you want to do power density measurement, that means field strength, you can load directly into the instrument your antenna factor by means of using a CSV file, and in that case, data will be directly calculated in dBm over square meter. We see an example later on. Whereas if you want to do IQ capture, in the same way, you have full flexibility of choosing the sampling rate and acquisition time you want, and even checking early the quality of the modulation. That is an example of a synchronization signal of a generic 5G frame. But you can do much more in the processing microservice developed by the university, with the same data, actually. So now if we put all this information together, we are able to show you at least a couple of case studies. One is from March 2024 in Bologna, and is proving the 2 key features, reliability and flexibility of this network. Reliability because data have been captured for more than 10 consecutive days in a row and calculated directly as a field strength exposure, so you save time by using the flexibility of the firmware. And over multiple 5G bands, even of different network operator, and this means flexibility. But there is another way of using this architecture, and is leveraging the saved data, the IQ capture, and the field strength measurement. So if we have access, as we have, to the time series of the field strength measurement, you can use this data for training new deep learning algorithm. But for doing what? Well, for predicting the effect on the human body if the human body will be in presence of a certain electromagnetic field exposure. And this is the work that is currently being done, and more on that will be reported later. And is based on realistic data. These data have been captured during 2022 and also later on in University of Tor Vergata. But as I said, this is the status quo. But we are trying to go beyond this limitation. So a few words regarding that. One I'm particularly proud of because it's happening in Italy, it's happening in Rome, where we work as Enrizzo, we have the location there. And again, once more, we are partnering with University of Tor Vergata and also now with the local regulation agency, Arpalazzo. For doing what? For leveraging on the flexibility of this network. It means adding even more additional node to the hardware radio frequency front end, by implementing also it with the first generation of our spectrum analyzer. Because these instruments are features in a way that make them ideal for measuring signal outdoor below 6 gigahertz. They are small size, low weight. Some of them are really water and dust resistant, proved, where some other are really multi-port receiver, 12 to 24 port, which make them ideal for capturing signal coming from either 3 or 6 sectors base station. And this is one aspect of how we want to improve the Swiptron. And this, let's say, also in Europe, because the Swiptron will be part at Mobile World Congress 2025 in the first week of March in Barcelona, where Professor Chiaraviglio will showcase in much greater detail what I've just introduced you today by discussing this brief slide deck, and we also run a demonstration on artificial intelligence and how to leverage the measuring data. Finally, just last comment by my side. As a restart, we are still doing something more, which is characterization of reconfigurable intelligence service, RIS, and this is done with some particular measuring hardware, like distributed VNA, and the idea is doing channel sounding measurement, channel impulse response in a flexible way, both at RF and microwave. So with that, thanks for the attention, and of course we are open to your questions.
Thank you. Time for questions from the audience. Anyone? So let me ask you some questions. I mean, it's not completely clear to me the application scenario, right? I mean, how do you use the measurements and how this can be incorporated in a kind of application, right? I mean, why do you need distributed measurements instead of point measurements like we usually do?
Yeah, that's a good question, and I don't know if also my colleagues that follow the job before me or someone can put some word on that. The idea is, is capturing signal in a transportable way, in the more access point as you can, you know.
Understanding then what do you do about that signal, right, that you capture?
Yeah, and so once you capture the signal, you can choose to do two different things. So once is having data, so the field strength data that you can leverage for understanding the effect on the human body, as we said, and streamlining this, so having the data always there for training artificial intelligence. This is the current status of the work, which is currently done by now. Whereas the other one, it's having more qualitative analysis. So you don't save power with what you normally do with a spectrum analyzer. You save power data, then of course you know the antenna factor and you have the distribution of the electromagnetic field. In that case, you are really demodulating the signal somehow. So you acquire the waveform, and you see if also the quality of your communication system is reliable. So you have transmission in terms of...
what you can do with the receiver, right?
Yeah, exactly. So you have, it's a sort of portable signal analyzer where you have both up to microwave, you have both RF measurement and signal demodulation. but everything is done in the same instrument, which is portable. You can put under the rain or in other situations.
I see.
So
Regarding the impact on human body, I mean, the evaluation of the biological part has been done, since 25 years now, right?
Yeah.
How can you correlate? I mean, how do you close the loop and add the information on the impact if you don't have the biological part?
yeah, of course, this is integrated with other data. I mean, I'm a part of the industry part, the one developing the capture of the signal. So
I mean, of course,
you know
you're
that-
interested in
yeah,
selling
yeah.
something, right?
It's really the
Within
idea
the
to
fear,
showing
it's okay.
what is the reason of using such an instrument, of course.
I see.
So
Okay.
that's for sure is not offering biological investigation. It's an
I
RF.
can
It's,
understand.
as I said before,
I
it's
mean, if you
RF
find-
front end, no?
Yes, of course. I mean, if we, as in general, if we find a good way of selling things, it's good thing anyhow, right? Thank you very much. Okay, this concludes this first technical session on experimental facilities. So the next one will be on emerging wireless communications. The chairperson will be Franco Chiaraluce. Fianco, thanks for accepting. Okay, yes, sorry. Just before starting with this, we got a request from our colleague in Politecnico di Torino. They just launched a call for ideas for a group of researchers and people that are interested in creating a startup on the topics of Restart. This is part of the second wave of cascade calls that Nicola mentioned at the beginning. So the one from Politecnico di Torino is already out. We will send out in the Restart community an email with the link, but you can participate, and of course this call for ideas then will be based on a selection, and then the winners will get some vouchers for being accelerated within the context of the Politecnico Torino accelerator. So consider to apply for this call for ideas. I mean, again, this plenary is on innovation, and the idea is that we know already that we have people that are generating innovation in Restart. Some of these ideas can actually be considered for starting new companies. So thanks. Franco?
Logistic information. So this afternoon the program is very dense, so we do not have the coffee break, but there is a coffee station, just in case from time to time you need some coffee. Okay, thanks.
Thanks. The title of the session has been already introduced by Antonio. The focus is on emerging wireless communications. We have 3 talks. And the first one will be presented by Francesca Meneghello from University of Padova. Francesca? Okay.
Okay. Meneghello. Okay. Thank you. I'm Francesca Meneghello, and I'm from the University of Padova. Actually, the work that I will present today has been carried out in collaboration with the University of Brescia, that is also part of the Restart program, and Northeastern University in the United States. And what we did was to try to analyze Wi-Fi networks, and specifically multi-user MIMO communication in Wi-Fi network, and try to see whether this kind of technology is secure or it is not. And actually, why should we be worried about these kind of things? Why should we care about the security of multi-user MIMO communication in Wi-Fi networks? Actually, because MIMO is key for next generation applications, is key to provide to the user the adequate communication service to deliver the next generation application like virtual reality, augmented reality, that we talk a lot about it today. And MIMO allow us to use the wireless spectrum, that is a scarce natural resource, in a more efficient way. And it allows us to move from a situation where we have to transmit multiple data streams, one after the other, over a single link, to a situation where we can transmit multiple data streams simultaneously over the same spectrum resources by leveraging the diversity gain provided by the multiple antennas deployed at the transmitter and at the receiver side. And actually, this technology is based on some assumptions and some procedure that we found out can be break by an adversary node that is inside the network. And actually, what we found out is that we are able to completely break the procedure and make the stream that should be intended to some specific station inside the network to actually not reach the destination at all. So we implemented this on real devices, not on simulation, nor on software-defined radios, but on commercial Wi-Fi devices. And I want to show you the demonstration. So this is the experimental setup that we developed at the University of Brescia. We have in this specific setup an access point, and we connected two stations. One of them is the malicious node that is a commercial Wi-Fi router where we modify the firmware. And the other station is a commercial smartphone, is a Samsung smartphone, and is the victim for our attack. So we set up the Wi-Fi network using multi-user MIMO. And we started hyperstreams in order to monitor the throughput. And you can see that in normal situation, the throughput is about 70 megabits per second, both at the victim and the adversary node. As soon as the adversary node starts the attack, the break attack that we developed, the throughput goes down to 20 megabits per second, as you can see there on the top for the victim node. So we demonstrated that our attack actually works in practice with commercial devices. And so we can run this attack on every Wi-Fi network deployed in the world and completely break the communication. So how did we do that? Well, we leveraged, as I said before, some vulnerabilities of the procedure that is used to set up the multi-user MIMO transmission. And the procedure is called channel sounding. And is triggered by the access point that transmits a packet, a sounding packet, that is called null data packet. This packet is used by the station to estimate the channel, so to estimate the way the signal is modified from the transmitter to the receiver. This estimation of the channel is then compressed for efficient transmission, and it is fed back to the access point. And the access point collects all the feedback, all the channel information from the different devices in the network, and use this information in order to pre-code the different data streams to be transmitted simultaneously to the different user in such a way that each stream is orthogonal to the channel between the access point and all the unintended receiver. In this way, we are able to transmit the multiple streams simultaneously without them to interfere with each other. So here we discovered that there is two vulnerabilities. The first vulnerability is in the channel feedback. This packet, this compressed channel feedback, is transmitted unencrypted. As you can see there, there is the screen capture from Wireshark monitoring session, and you can see the information about the feedback that are encoded in these phi and psi values is transmitted completely unencrypted. You can see the values. And the access point assumes that this information is obtained by following the standard IEEE 82.11 procedure. The second vulnerability is that the procedure that is used by the access point to implement the precoding, so to obtain the precoding weights for the different streams from the compressed channel feedback, is written in the standard. It's a deterministic procedure that is known by everyone. So an adversary node can leverage these two vulnerabilities in order to design a malicious feedback that completely destroys the communication, as I showed you before. So this can be done by eavesdropping the compressed channel feedback that, as I said, is transmitted unencrypted. So the only thing we have to do is to capture it over the air through whatever we want, Wireshark, and decode the information. And using this and using the knowledge about the procedure used by the access point for precoding, it can create a malicious feedback that lead the access point to compute an incorrect precoding. So the streams will be transmitted with incorrect weights, and this lead the legitimate station to experience a loss in the throughput of more than 65%. So another interesting thing is that we found out that the malicious node does not need to modify the entire feedback in order for the attack to be effective, but it can keep unmodified the 83% of the feedback and modify only 70% of it. As you can see in the picture, where the feedback of the victim is the one in blue, the feedback of the adversary before the attack, so the legitimate one obtained through the standard IEEE 82.11 procedure, is the one in black. And in orange, instead, we have the feedback with our modification, so the malicious feedback. And as you can see, only a small portion of the feedback has been modified. So now we have two questions. The first one is how we can select the subchannels to be modified, so the 70% of the feedback that we should modify. And the second question is how to modify it. So we started by doing some experiment, and at first we started by applying some random modification and also selecting the portion of the feedback to be modified at random. But we found out that this does not have any effect. Here you can see the line is the throughput before the attack. Instead, the boxes represent the throughput after the attack for two different approaches of the random attack. And actually, even if we increase the number of subchannels that we modify, the throughput does not decrease. So in order to find a proper malicious modification to the feedback, we analyze the complete procedure that is using Wi-Fi network to enable multi-user MIMO transmission. The entire procedure consists of the channel sounding that I explained before, then we have the precoding, and then at the receiver we have the interference cancellation, so the decoding. And the procedure can be summarized by these equations, where we have x that is the stream, the transmitted stream, and x at that is the received stream. And they are linked by three matrices, where W is the precoding applied at the access point, H is the channel matrix, and G is the decoding matrix. And in multi-user MIMO system, these matrices, W and G, are designed in such a way they compensate the effect of the channel. So the matrix multiplication, G by H by W, should be an identity matrix. So from here, we get an intuition about what the adversary should target. And as you can imagine, the adversary should try to make this product, G by H by W, as different as possible from the identity matrix. So the adversary should transmit a malicious feedback that create a W that make this product not be the identity matrix. So mathematically, we formulated the problem in this way, where we maximize the mean square error between the product, G by H by W, and the identity matrix, with some constraints that are linked with the constraints about the feedback in the standard. And at this point, we thought that we arrived at the solution, but actually no, because these two matrices are not known by the adversary. So H, the complete channel matrix, and the matrix used for the decoding are not known by the adversary node, because the adversary node is only able to capture the compressed channel feedback, so a compressed version of H. So we derived a surrogate problem that only depends on the compressed feedback, and that problem can be solved at the adversary node. We solved it through interior point optimization, and also leveraging the fact that the surrogate problem has true unconstrained solution that can be used to initialize the solver. And at the end, we end up with the malicious feedback. I didn't put all the detail here in the slides. You can find them in the paper if you are interested with all the mathematical derivation to arrive to the surrogate problem. Because I want to go to show you some more results. Actually, I already showed you that this attack works in practice with the video at the beginning. To evaluate it in a more systematic way, we implemented an experimental setup where the victim nodes were some routers so that we can monitor the streams through iPerf, and we can obtain some statistics about the attack. So here we have the access point that is the same that you saw in the video. Then we have four different adversary nodes. 4 of them are implemented through routers, and then we have the smartphone, and the adversary node that is the one on the right. All of them are implemented through commercial devices, and we only modified the adversary node. So the access point has not been modified, and also the other victim and the smartphone. And here you can see the results with a setup with 2 stations in the network, where one station is the malicious user and the other station is the victim. We tried out with 2 different victims, the victim A, that is near to, on the same side as the adversary, and also victim D, that instead is near to the access point. And we found out that for both the 2 configurations, the throughput after the attack that you can see in the represented with the boxes decrease also when only modifying 40 subchannels out of 242. Here you can see the statistics about the packet error rate that actually says the same thing. And at this point, one can have a question. And the question is, okay, but is this results due to the fact that the stations are not able to decode the stream, or maybe it is the access point that is no more working in multi-user MIMO mode? And actually, we found out that the access point does not recognize the attack and continues to use multi-user MIMO. We had the confirmation by using 2 sniffers that you can see there. And with the 2 sniffer, we captured the frames, and we tried to check whether the frame check sequence was correct or not. And here you can see what happens before the attack. So before the attack, we have the rate is about 6 packets per second, 6 to the power of 3 packets per second, and all of them pass the frame check sequence check. After the attack that starts here, the rate remains the same, but the number of packets that fail the frame check sequence increased dramatically. So actually, this is the confirmation that the access point is not recognizing the attack, and it continues to work in multi-user MIMO mode, and the stations are not able to decode the traffic anymore. We also evaluated it with 4 stations, so with the maximum that we can have in multi-user MIMO networks, but I will leave this for you. If you are curious, you can find the paper at that QR code. And I want to conclude discussing a bit about the countermeasures. So what can we do? One thing that we can do is to encrypt the feedback, but actually this will increase the latency, and it is not good for multi-user MIMO because we should use the channel estimation as soon as possible for the precoding. We don't have to use a channel estimate that is outdated in order to implement the precoding, otherwise it is not effective. Another approach can be to use machine learning tools in order to make the work of the attacker harder, because the procedure will no more be deterministic, and so the attacker cannot use it for designing the malicious feedback. But actually, all Wi-Fi devices that are nowadays deployed in the world are vulnerable to this attack, and we have more than 21 billion of devices. So actually, we have a problem, and I think that as a research community, we should be aware of it, a little bit worried also, and try to find a proper solution that maybe is a combination of encryption and machine learning, but it should also be compatible with the multi-user MIMO network. And with this, I thank you, and I conclude the presentation.
Thanks, thanks, Francesca. This final message is particularly bad in the sense that, questions or comments?
So my name is Giuseppe Ferraris from Politecnico di Torino. I understood that you have found a security issue in a procedure that is part of an IEEE standard.
Yep.
So you published it in a paper, and that's okay, of course. But I wonder if you are considering to produce a contribution to IEEE to highlight the problem and maybe suggest some countermeasures.
Yeah, we are actually also working on that, so to be in contact with the IEEE standardization team in order to find some solution for this issue, because actually it's something that we should be aware of. Actually, it's difficult to implement some countermeasure in networks that are already deployed, so in the devices that are following the standard up to AX, because this vulnerability is linked with the standard procedure that we cannot change. Maybe we can do something for next generation network, but the problem is always that all the new standards need to be back compatible.
Yeah.
So,
yeah, that's the point.
Yeah.
Thank you very much.
It's a big issue, actually.
The possibility, I had just a few words, the possibility to have an impact on the standardization bodies, if I correctly remind, is one of the summations of Restart in Mission 7. It is included, so it is important. In this case, the problem is that we have not the solution, and so it is difficult to... Yeah.
Yeah. Yeah, also the code will be publicly available, so for the implementation, for the attack and everything.
Yeah, from a theoretical point of view, don't you think that there is the possibility to explore more in depth the problem in such a way that your solution is machine learning or encryption, which are conceptually simple solutions?
Yeah, we should rethink the way multi-user MIMO is implemented, actually. We can think about not using explicit feedback and using implicit feedback, but they showed that there are problems in doing that. It is less efficient to do that. So I think it's a complex problem that should be addressed in several ways from different perspectives.
Okay, other comments?
Thank you. I think it's I'm impressed. It's a well executed work, and I like it. But I had to be that guy that asks you, how does it compare to other jamming techniques?
Okay.
General jamming techniques.
This is the question of all the reviewers.
Related techniques.
Okay. If you want to implement jamming, you should have a node, and jamming is you should have a node that do an active attack. So that transmit some packets that are more powerful than standard packets, and that destroy the communication. Actually, here we are leveraging a procedure that is in the standard. So the malicious node is not transmitting more packets than the packet it should transmit if it would be a legitimate node. We are modifying the feedback that that node usually transmit as a legitimate node. And this transmission is done every 10 milliseconds. So we are using something that it is already encoded in the standard to be done, and we don't have to include additional packets and additional information to be transmitted for jamming. Also, jamming, so there are several techniques to discover a jamming attack, because you can analyze the spectrum and find that there is a jamming attack in place. While for this kind of attack, you cannot use the detection technique that you can use with jamming. So it is less discoverable.
By the way, there's a feedback. There's also something that I realized right now. There's a feedback mechanism also in 5G and 4G.
Yeah, I know.
So
we are working on it.
You're working already. All right.
Thanks to you. So actually, we discovered another vulnerability that is exactly that vulnerability. So the access point is not checking the MAC address. The access point is only concerned about the timing. As soon as when the feedback arrives on time, it assumes that that feedback has been transmitted by that specific station, and it is not checking the MAC address. We tried it.
Okay, thank you again, Francesca. We must stop the questions and continue discussion afterward. Well, the next talk is by Michele Godeas from the University of Trieste.
Thanks. Godeas. If you can open it with Google Chrome so that I can use the remote. Maybe we will resolve this problem. Okay. So, hello everyone, I'm Michele Godias from University of Trieste, and today I'm here to present a study entitled Blind Source Separation for Massive Machine Type Communications, authored by myself and Professors Alberto Carini and Fulvio Babic, who is here with us today. In this paper we studied the use of blind source separation as a replacement for coded random access strategies in massive machine type communications. In particular, we propose a BSS algorithm within the slotted ALOA framework, while also determining the number of active users in each slot. We evaluate the achievable performance while also pointing out the factors that affect the total number of detectable users. So in what follows, I will first introduce the topic of the paper. I will then describe the proposed approach. We will see some simulation results, and I will finally come to my concluding remarks. Let's consider a grant-free massive multiple access scenario in which lots of machine type devices sporadically wake up to transmit short packets to a base station, which we assume to be equipped with a large number M of antennas. This scenario has gained lots of interest in recent years, and it's often referred to as massive machine type communication. In such a scenario, we assume each frame, the transmissions are organized into frames consisting of NS slots. In each frame, an unknown number Ka of users contend for the transmission channel with as I said, Ka unknown at the base station. Each user randomly picks R slots in which to transmit replicas of his packet, of his payload, which is assumed to be formed of information bits, in particular data and replica's position, and a cyclic redundancy check, and a BCH error correcting code. We assume a QPSK constellation modulation with gray mapping, leading to a total of n transmitted symbols. And we assume a block fading channel with coherence time equal to the slot duration. So to address this type of communications, lots of CRA schemes have been proposed and studied, typically relying on codes in the form of pilot sequences to extract messages. We propose a different approach based only on blind source separation. In particular, avoiding the use of pilot sequences shortens the message length, reducing those power consumption, and in a framed scenario, allowing a larger number of slots to be considered, enhancing the detecting capabilities at the base station. So let's proceed by mathematically introduce the problem and showing how its complexity can be reduced by estimating the number of active users in each slot. I will then describe the BSS algorithm along with what we call the double gradient descent approach and the successive interference cancellation techniques adopted at both slot and frame level. So, at the receiver side, the signal impinging on the M antennas of the receiver can be expressed as here reported, where NA denotes the number of active users in a slot, and XK and HK are respectively the message sent by the kth user, and HK is a coefficient channel vector. The aim of the BSS is to iteratively find a separating vector decay that such that its Hermitian product with the observation matrix Y resembles as closely as possible one of the sent messages. We also assume that the first symbol is fixed in order to resolve the aphase indeterminacy that arises. We will see in the future slides that the BSS algorithm will be implemented by means of a gradient descent approach, and to resolve, to reduce the number of parameters to estimate, we firstly perform a singular value decomposition of the observation matrix, and we consider only the first NA singular values, obtaining the reduced matrix Y tilde 1, as reported here. Obviously, this requires the knowledge of the number of active users, which we propose to estimate with the normalized forward difference of the average singular values of Y. And as we can see in the figure on the right, where we considered 20 active users, this formula exploits the expected drop in the magnitude of the average singular values at the index corresponding to to NA substantially. So let's move to the core of the algorithm. We aim to find a separating vector such that it's that linearly combines the rows of the observation matrix into the QPSK constellation. And to do so, we consider a constant modulus algorithm, which basically aims to minimize the average squared distance of the output samples with respect to the unitary circle. And this minimization is performed through a gradient descent, whose solution is here reported. And at the end of the descent, we correct the phase of the output samples, and we attempt a detection. If this detection fails, we restart the gradient descent up to a maximum of n-t times. Each time instead a signal xj is successfully decoded, we implement intra-slot successive interference cancellation, by estimating the channel coefficient vector related to the signal and by computing the deflated matrix as reported here. In this way, we are able to minimize, drastically reduce the probability of detecting again the same sequence. Due to the non-orthogonality of the transmitted payloads, as the detecting capabilities of the blind source separation algorithm decreases as the number of cancelled contributions increases. To address this problem, we extended a method taken from the literature, which we will refer to as a double gradient descent, which basically consists of performing a first gradient descent on the deflated matrix and to use the resulting parameter vector to estimate a new one from which to start a second descent on the original mixture Y1. In this way, we are able to start the second descent from a parameter vector that's independent from the previously extracted sources, while being sufficiently close to a new solution. Okay. As for CRA, at the end of each slot, we assume the base station to send acknowledgements. In particular, we will see in the experimental results that the BSS algorithm behaves quite sharply in the sense that either all the messages are detected or none of them are. So we will assume that acknowledgements are sent only if all the signals within a slot have been successfully decoded. At the end of each frame, we perform intra-frame interference cancellation. In particular, the base station for each detected signal in the frame takes advantage, exploits the replica position embedded in the payloads to cancel the contribution of this signal from all the slots where its replicas have been transmitted but not detected, and a new search is attempted. This typically leads to a chain of detection and intra-frame cancellation that ends whenever all the messages have been detected or the algorithm is no longer able to find new ones. So let's finally come to our results. In this slide compares the error rate of the normalized forward difference in the estimate of the active number of users while varying the number of antennas at the receiver and the signal-to-noise ratio. We can clearly see an improvement with larger values of M and higher signal-to-noise ratios. In this slide, we compared the performances on a single slot of the double gradient descent based blind source separation algorithm, while also comparing with the standard single gradient descent. In particular, and we also evaluate the effects of different payload lengths. In the first columns of this slide, we considered respectively a high noise and a low noise scenario with BCH encoding on the bottom and without it on the top. We can see that the only scenario in which there's a visible difference between SGD and DGD, single gradient descent and double gradient descent, is the high noise scenario without BCH encoding and with short packets. In all the other cases, they behave quite almost the same. We also point out that the BSS performances improves with the length of the payload of the payload. An important result comes from the last column of the slide, where we take into account intra-frame cancellation. In particular, we consider a fraction P of users, which we assume to know from other slots in the frame. And we can see that increasing the number of, as the number of cancelled contributions increases, as for P equal 0.75, there's a visible difference between DGD and SGD, both with and without BCH encoding. here we can see the effects of the number of restarts of the gradient descent on the packet loss rates. And there's an improvement that almost linearly depends on the logarithm of NT. And we will finally come to our most important slide. Here we compare the performance of the BSS algorithm and a standard CRA scheme on the entire frame under 9 different conditions, varying the packet, the message length, and the number of retransmissions are. We consider 128 antennas at the receiver and a signal-to-noise ratio of 10 dB, and NT equal 8 for the BSS. And the figure on the left, no, let's say this before. We've seen from the previous results that increasing the number of transmitted symbols enhances the blind source separation capabilities, but in a frame scenario, this also reduces the number of available slots, and so increases the average number of users per slot. And we can see that from the figure on the left that the latter effect dominates, making shorter messages more advantageous. The best performance is achieved with n equal 128, r equal to 2, where up to 2,500 users can be supported by the network in a single frame with packet loss rates below 10 to the power of minus 5. For comparison purposes, we also evaluated the performance of a CRA scheme, and we can, where in this scheme a pilot sequence of 24 symbols precede each transmitted payload. And we can clearly see visible improvement, visible difference between the two schemes. But we also must point out that the results on the right are actually worse with respect to the original ones in the paper reported below, because here we assumed 128 antennas instead of 256, and the CRA method taken into account is very sensitive to this parameter, while ours is more robust in a certain way. So let's come to my concluding remarks. We have proposed a BSS algorithm within the framed, the slotted ALOA framework for massive machine type communications. We have seen how its performances are somehow comparable or even better with respect to the standard CRA ones. But we also point out that BSS and CRA can easily work together to enhance performance, and in this sense we have found very interesting results that will be published in the future works. I really thank you for the attention.
Thanks, thanks, Michele. Questions or comments? I think this is an excellent work, surely. When applying these algorithms, I'm always a bit worried about the complexity.
Yeah, of course.
And which obviously have an effect on the scalability and so on.
Yeah.
And what you can say?
No, I can say that I did not mention a few things. For example, as I said, the algorithm is based on a gradient descent, which is obviously more complex from a computational point of view with respect to a standard CRA method scheme. But the constant modulus algorithm implemented is well known. It's used in many algorithms such as independent component analysis, and very fast implementations are available. And moreover, where in the slide where was visible the gradient solution, there was a small detail in the update of the gradient of the parameter vector. I wrote a subscript mu optimal step size, optimal step size. In particular, at each iteration of the gradient descent, an optimal step size can be easily evaluated by solving a third-degree polynomial, and this enhances quite considerably the convergence speed.
Okay, another quick question. Your experimental results are basically simulation results.
Yeah.
Is it right? But do you think, do you aim to realize a practical demonstration?
I will like, I don't know if Mr. Babis is want to say something about.
It would be really important, I think. So.
It will be obviously very interesting to see in practice if this algorithm can work.
Okay. In progress, yeah.
Yeah.
Thanks again.
Thanks.
Okay, the last talk of the session will be given by Giulio Cossu from the Scuola Superiore Sant'Anna.
Okay, thank you. I'm Giulio Cossu, assistant professor at Scuola Superiore Sant'Anna, and in this talk I'm going to present the work that we are doing within the framework of the project Rigoletto, where we are developing Li-Fi system, an optical wireless communication system. This work is in collaboration between Scuola Superiore Sant'Anna and Optics Institute of CNR in Florence. Okay, what is optical wireless for the people who don't know? So the optical wireless is a technology that uses visible or near infrared light to transmit wireless information. Potentially can give much higher bit rate compared to the correspective radio frequency solution. And if used in indoor scenario, you can think to use and to exploit the synergy between illumination of the environment and data transmission. But the indoor is not the only application that we can think. We can use for positioning, for high accuracy positioning, for Internet of Things, underwater communication, and exploiting the high bit rate, high throughput that the optical wireless can achieve. We can think to use it in data center or even in space application. So within Rigoletto, we are developing a bidirectional link which must be integrated with a local area network. We are thinking to use a system between a communication between the ceiling and the desk, where the downlink is performed using visible light, so white light, and the uplink made with infrared light. The integration is made by using Ethernet signal. And okay, next. So the main novelty introduced by this, the proposed system is the use of luminescent solar concentrator. Basically, these are a plastic slab where there are dissolved some fluorophore, and the light that is impinging this slab is absorbed, and then the emitted light is guided through internal reflection to the side of the slab, where we can place a photodetector. This basically makes that we can have a very large collecting area, even larger than tens of centimeters, while we are using a small photodetector. So we are maintaining the electrical bandwidth of a small photodetector while we have a very large detection area. And we are also having a really high optical gain, but maintaining the enlarged acceptance angle of the receiver. So here a picture of the experimental setup. We have the transmitter on the left, the receiver on the right, and all the equipment that we are using. And now we are characterizing the system, so we are still in the horizontal configuration at 2 meter distance. On the picture on the right, we can see a detail of the receiver where we can see the slab, which is basically red, because the red is the wavelength of the remission of the fluorophore that we are using. Here are some other detail of the setup. As optical source, we are using an high power white phosphorescent LEDs. And since it's using phosphorus, so the electrical bandwidth of this device is quite low. The measured one is only 2.9 megahertz. And usually to improve the bandwidth, an optical blue filter is used at the receiver side. In such a way you can cut off all the slow phosphorescent part of the optical signal at the expense of reduced power. 2/3 of the power is lost. In our solution, we are doing something different. We are not using a blue filter at the receiver side, but we are distorting the signal at the transmitter. In such a way, we can have a frequency response more flat. We can see on the red curve. At the receiver side, I said we are using a luminescent solar concentrator with an area of 25 centimeters square, much larger than a common photodiode that you can use for optical wireless communication. As a photodetector, we are using an APD and then a voltage amplifier to restore the compliant voltage of the Ethernet signal. On the figure on the right, we can see the overlap between the emission spectra of white light, the black curve, and the absorption spectrum of the luminescence concentrator. We can see there is a really good overlap, and the red curve is the emission of the re-emission of the light by the concentrator, which is shifted to the red color. So here we have also the characterization in bandwidth of the receiver made by a laser source. We can see that we can have a bandwidth of 15 megahertz, which is more than enough for our goal. So before to characterize the system with the real Ethernet signal, we first emulate this signal, generating a 10 megabit signal Manchester encoded with an FPGA. So it's used as a source and detector, an FPGA. And we measure the bit error rate as a function of the received radiance and as a function of the angle of the incidence of the signal compared to the receiver in two configurations, one with our proposed solution and the other one using only the photodiode, so only the APD. We can see the performance are clearly better with the proposed solution, but I want to highlight that there is an enormous margin to further improve this performance. So then we have the real Ethernet transmission. So we perform a unidirectional transmission between two Ethernet network cards using UDP protocol. We send a real-time HD video signal. As the receiver side, we use a Raspberry Pi 4 to show the video on the screen. and actually we see no error during the transmission, but we can see there is a lot of improvement even from the eye diagram. And here I have a video. Let's see if it works. Okay, just a short video of the transmission. So we have the LEDs, and here the concentrator, and here the video streaming that is showing the transmission. Is 2 meter distance, and here the common test put in the end in front of the receiver, where the streaming clearly stopped, and after a few seconds that the buffer restore, the video is also restored. This demonstrates that our proposed solution can transmit an H video on using optical wireless communication. But in order to test the capacity, the potentiality of our system, we also perform the test with the more advanced modulation format, the discrete multitone, which is the real-based version of the OFDM, which works using a bit and power loading, so is able to adapt the capacity of the transmission as a function of the available SNR, basically signal-to-noise ratio. And we demonstrate that we are able to achieve up to 71 megabit per second, and guarantee at least 25 megabit per second on an area with radius of 2.5 meter. We perform similar analysis also for the uplink. In this case was made with infrared light. We test both wavelength 850 and 940 nanometer. The power used was well below the high safety limit. In this case, there was no need to use an equalization system. The electrical bandwidth of this device is much higher, more than 20 megahertz per second, so no need of equalizer. And also in this case, we perform the Ethernet video transmission, unidirectional video transmission, and also in this case was working perfectly, no glitch, no errors. And then I'm going to conclude. So I present a novel optical wireless communication system based on luminescent solar concentrator. So this kind of device are able to allows you to have a very large detector area without limiting the electrical bandwidth of the device, of the receiver, and also maintaining the acceptance, a wide acceptance angle. We showed that this system can work on a real existing network. So we tested which is compliant with Ethernet signal. We transmitted an HV video in both directions, so uplink and downlink. Up to now, unidirectional system. And so the next step will be actually to perform a more realistic scenario, putting the system in a vertical way where we are transmitting simultaneously the two streams. And also we can perform analysis using different luminescent solar concentrator.
Okay, thank you, Giulio. Okay, we have time for a couple of questions. Okay.
Thank you, Giulio, for your presentation. When you showed the results related to the bit loading, It is something that is working real time, or you measure the channel in some configurations, for example, distance or angle between transmitter and receiver, measure the channel, then perform the optimization and allocate power and modulation format according to the channel, or it is real time?
Okay, in this demonstration, we perform everything, let's say, offline. We analyze the signal on the oscilloscope, everything on offline. But we also proved in the past that can be performed using an FPGA and doing everything on real time.
Other questions? Your contribution is quite appreciable in terms of designing, realizing new devices. My question is more general. How much can we trust in this technology? Is it a competitor of Wi-Fi or?
I'm not fan to say that the optical wireless is a competitor of Wi-Fi. They have to be used in different scenarios because Wi-Fi is working perfectly as for a common person at home, but there are some, let's say, niche application where we can use the optical wireless instead of Wi-Fi, where you need much more security. The colleague before was saying that we have huge problem having Wi-Fi and the people that can eavesdrop the information. But in case you need high security communication, optical wireless could be a solution. Where there is no light, you cannot install anything.
Yeah, but for example, a man in the middle is always possible.
Sorry?
A man in the middle, in the sense that obviously the distance covered is very small, but anyway, intercepting the signal,
yes,
it is a problem. So
of course, this is another issue. Of course, you need to think that you have to use this configuration on particular niche application. But there are some scenarios where you can use this technology not only for, let's say, to use the communication for internet at home. I'm thinking something different. For example, to use inside, for example, the spacecraft, to communicate between the equipment that you have within a spacecraft. In that case, you don't have a person that is blocking the signal.
Sure. A final question. You mentioned some bit rate values which are not so impressive, but you think that it is possible to increase them?
Absolutely. This demonstration was limited to 10 megabits per second, especially because we want to integrate with a real network. So Ethernet signal we are using, so we cannot use 25 megabit or 50 megabit per second. But there are demonstrations maybe not using the solar concentrator, but using more common solution that can improve the bit rate to gigabit even per second.
Okay.
It depends on the application.
Okay, thanks again. This concludes the session. I thank the speakers and the audience for attention.
Thank you. So now we move to the next session, which is on orchestrators and digital twins. The session chair will be Claudia Campolo, Unimed. So Claudia, thanks for chairing the session. I just remind you that this is a session with 4 papers, so the presentation will need to be a little bit shorter than the others, right? So we need to stay in 1 hour. Thank you.
Hello everyone, welcome to this session. Well, the session will be about topics that have been discussed a lot today. Digital twins and orchestration issues. Now we will go deeper into these topics. So the first speaker is Antonio Albanese from Italtel.
Hello, I am from remote. Hello everyone.
Okay.
So if possible, I can share my screen.
I don't know if the guys there can support.
Can I share my screen?
Yes, you could try. Let's
Okay.
Works?
Can you see it?
Yeah, we can.
Okay.
Please, the floor is
So
yours.
I can start? Yes. Thank you. Hello, everyone. Sorry for not being there because for another meeting at the same time. I am Antonino Albanese from Research and Innovation Manager at Italtel, and today I will talk about smart networking for distributed AI and environmental control. This work are based on the activities carried out during Watch Edge focused project, and this about addressing some specific business need that is monitoring wild animals in rural areas. The idea is to try to demonstrate how some research topic result can be leveraged for addressing some business need and try to find a way for providing enhancement in the market for business application. The environment we are talking about is monitoring wild animal in rural area. These animals, like boar and deer, can cause significant damage, including, for example, crop devastation, car accident, and possibly also spread of African swine fever. We have to address different challenges because in rural area we have different properties, different owners. We have also animals that can move from one areas to another areas. And in order to monitor and analyze this movement, we need to install in the field different equipment providing a specific technology. For example, smart sensors, photo traps, UAVs, edge servers, and also local network connectivity. This is a problem in the rural areas. Again, another important aspect to be considered is the use of AI for computer vision and for identification, classification, and this needs to provide enough computational capability at the edge in these rural areas. In order to also reduce cost, the idea was to build an infrastructure in a system that will allow to share this monitoring infrastructure in order to reduce the cost per single farm. In order to design this solution, we addressed different research topics. For example, the idea was to design this multi-site agile system architecture using a fleet of drones, also addressing the problem of energy efficiency in using drones. Another important topic was the use of SD-WAN for and network programmability at the edge for addressing a connectivity problem. As well as another important aspect is the network and service orchestration in the edge cloud continuum. Also AI for supporting this application for surveillance, also leveraging fleet of drones, and also leveraging distributed AI, including also the use of hardware accelerated smart sensors. We come up with this architecture. This architecture is based on islands at the customer site that includes different technology equipment, edge servers, DCP for the SD-WAN access, drones and fleet of drones, together with the whole set of smart sensors and traps and smart cameras that will be installed at in this rural site. The idea is to connect these islands using SD-WAN technologies, and for this we need a specific capability for the orchestration. As outcome of this analysis, in this first 2 years of the project, we deliver a flexible platform that can be used for addressing business-sensitive application. The first application will be environmental monitoring and surveillance, but this can be also moved to smart agriculture, IoT, Industry 4.0, and smart city as kind of architecture. This architecture support also is supported by a multi-tier orchestrator for resource management. The capability to deploy these funnels in the rural areas, also monitoring it and managing it. Another important aspect was the deployment and support for enhanced IoT devices for realizing radars, smart sensors, and smart cameras. All the algorithm for supporting the and manage the connectivity by SD-WAN technology, and also support of AI as for the managing the network optimization, as for the providing support, the AI support for the application itself. So providing a possibility to the end user of using this the AI technology. For managing this very complex architecture, we design an orchestration that includes 4 main innovation. First is about the platform orchestrator in order to manage this multi-domain architecture. Another important aspect was, as I said before, the SD-WAN orchestrator in order to manage all the connectivity with specific needs between the different islands, also for supporting this distributed AI. And at the customer site, we developed a specific orchestrator that includes the orchestrator for managing these fleets that was developed by University of Catania, and also another functionality that developed a solution for managing function as a service in a distributed manner. In the last year of the project, so this year, we will deploy a POC in Parco di San Rossore in Pisa, providing different equipment on field and demonstrating how this technology can be used in rural areas. This will be not so easy, but we'll address for sure this topic. We have already investigated the location, and we will have this year a different meeting in order to try to install and deploy this technology solution in these rural areas. Lastly, I would like to talk about a possible exploitation and market perspective of these activities. In our consortium, we have 3 main. Apart from the university, we have also three companies: Sensor ID, Nextsource, and Italtel. Each of these company address its business needs. In particular, Sensor ID is deploying a smart camera, integrating peripheral drivers, enabling also possibility to run AI inference at the edge directly on this platform. This device is going to be industrialized and also adapted for different use cases, for example, also in smart city and in manufacturing. For sure, network will leverage this orchestration, trying to industrialize it and move this and to use for multi-domain networks control. Italtel, as system integrator, is working on end-to-end solution for addressing different vertical in the remote monitoring scenario. As possible exploitation of this technology at the edge, we think that can be used for example, for intrusion detection, panic detection, man down, as for the in the park, for example, but also in Industry 4.0 or in other environment where there are men at work. And in general, another application can be providing people safety in a smart city using cameras, or also drones, and try to prevent attack or other safety problem within a smart city. And we know that there is a lot of problem. We have a lot of problem in this case, in this last years. So this is my last slide. Thank you very much for the attendance. And if you have any question, I'm happy to try to answer you. Here you can find the list of partners that are in the WatchEdge project.
Okay, thank you, Antonio, for your presentation.
You're welcome.
Okay. Any question, any comment from the audience? Okay, maybe I can ask something. Thanks
Yes.
all. I would like to thank for this presentation that addresses very different topics and several challenges that are all very related to the restart topics. I would like to ask you about this idea of the smart camera that can be adapted to different environments. You have mentioned the chance of developing a kind of device that can match a different scenario with AI embedded, if I'm not wrong. Do you?
Yes. The idea.
Okay.
The idea is to build an edge device. Try also to optimize. This is by Sensor ID, but I think I can say something on this. So the idea is to build an edge device that has to be optimized in terms of power consumption, but also capable to host a specific computational need for try to run inference directly near the camera, and try to move not all the video stream from the camera to the edge, but directly a result of the inference. And the idea is to, as we cannot include a lot of computational capability in this very low-end devices, the idea to use federated learning, distributed AI, in order to be able to run inference and also use this data also for retraining the models, considering the acquisition of the new images, and share this data between islands using this distributed architecture.
Okay, thanks for the clarification. Another question, if I can. The session is about orchestration, orchestrator, and digital twins. Have you considered the chance of developing a digital twin for these devices that are spread on the ground?
Not in this project. In this project, WatchEdge is a focused project, so we for sure focused on the specific needs of monitoring these rural areas. But digital twin, in my opinion, in this environment can be used as a support for especially not only in the wild for monitoring these wild animals, but for example in smart city, also in case of panic detection and other industry 4.0. For sure, using digital twin can help in improving, let me say, and this the application, and try to get in advance some indication that can be used for improving the application itself. But in this specific project, we are not using digital twin.
Maybe it could be a need for the future.
Could be an improvement, yes, for sure.
And to find some cooperation with the ongoing project within Restart. Okay.
For example, lastly, I would like, for example, digital twin. If we are talking, for example, of environmental monitoring, and we are talking about also for water, for example, we can use, for example, digital twin in this case to anticipate some problems with, I don't know, when you putting also together meteo data of the meteo, data of the coming from the sensors, and try to anticipate some possible problem, preventing you know what we are seeing in the last month. So for sure, it's an important aspect to be considered in this kind of application.
Okay, thank you once again.
You're welcome. Thank you.
So next speaker is Francesco Malandrino. Francesco is a senior researcher at CNR Torino. So please.
Malandrino, the slides. Yes, thank you very much to Claudia for the introduction. Thank you all for still being here. It's been a long day. This is one of the 30% of joint works. It includes people from University Mediterranea, CNR Politecnico di Torino, and even University of Pisa, who are not part of the Restart project. And I would say no wonder. This is a project, paper, a work about metaverse, so of course everybody wants to be in that. But anyway, on the more serious note, XR, extended reality, is kind of an umbrella term that includes fairly different technologies. We have virtual, augmented reality, mixed. So it is a fancy topic, yes, but also it is a very interesting topic to work on a scientific side for two main reasons. The first one is this is a textbook example, a very clear, a very strong case for network and devices that cooperate in order to provide an advanced service. And the second reason is a new type of device that we have in this type of scenarios. We can think of this kind of head-mounted glasses. So let's call them the XR wearables. Now, XR wearables are not the first wearables that we encounter. Now we all have smartphones in our pocket. We have smartwatches. Why are they different? They are different for a couple of main reasons. One reason is the load. So the things that they have to do, the operations that they have to perform in order to provide us with this seamless, immersive experience and so on. And we can see some examples here. Now we have pose estimation, localization, we have machine learning. Of course, we have a lot of multimedia being served to us. Given this list, and this is a very partial list, it should come as no surprise that the first wearables, if you remember, no, they wear these nice glasses, but then they had a cable connecting to a computer under the seat. So point is, wearables, XR wearables, have to make more operations than other type of mobile devices. And also, to state the obvious, they must be worn on our faces, which means that they must be small, they must be lightweight, so we cannot put fans in them because it will be noisy. We cannot have advanced cooling systems. So if they overheat, it's a problem. They give us this type of low temperature burns starting at 43 degrees, which for a device that makes all these operations is not actually a lot. So the bottom line is in XR, the XR wearables are more subject to overheating than a typical mobile device. And if you are not a student, that sounds familiar. So we have a constrained device which has to make a lot of things. Immediately we think offloading. And indeed, offloading part of this load to the edge is one of the main strategies that we can use in the wearable scenarios. However, we have two problems here. So number one is the edge cost. So if you are a vertical providing the XR service, you don't want to offload too much. And even more critical, if you are using high frequency technologies, millimeter wave, sub-terahertz, and you probably are because you want the capacity, then offloading too much means that you are more likely to encounter a blockage, which means that you avoid overheating, but you increase the probability to disrupt your service and to have and to upset your users in a different manner. So essentially, there are two main ways that you can fail. You get a service request, then you make a decision, you can serve it locally, and then you may fail because of overheating, or you can try to serve that through edge offloading, but then if it works, you pay the fee, and if it doesn't work because of a network blockage, for example, you still lose the request. Now, given this scenario, it's very important to characterize. Ideally, you would like a perfect characterization. Now you would like to be able to foresee exactly both the thermal behavior. So will serving one more request bring me beyond that 43 level threshold? And ideally also to foresee the blockage so that you can make your offloading decisions in the most effective possible manner. So we said offloading is our main decision, which are the KPIs. Some are the usual ones, I should say. So we need to fulfill service requirements. We have end-to-end delay that we must meet. We have a network capacity constraint, edge capability, a battery, of course. So I would say this generation, this side of the constraints are common to all the other wearables and mobile devices, but subject to the XR wearables, we have additional constraint, additional things to take into consideration, foremost of which is temperature. So the temperature of the wearable evolves more or less like this. So when you are serving your service locally, so these are these pink areas, the temperature goes up quite quickly. And then when you stop serving locally, the temperature goes down in a more slow manner. Now, how quickly and how slowly very much depends on the feature of the wearable. These are thermal models built with COMSOL, whatever that is. And the point is you want to make your decisions. So these are your decisions. So the decision is whether your axis here should be pink or white. So you want to decide the pink areas in such a way that the temperature never goes above that critical threshold. And again, as we said, all devices heat, all mobile devices heat. So why is that different for wearables? It's not a concern that is unique to the wearable, but for the XR wearables, it is uniquely relevant. Put in a very concrete terms, it is much more likely that I have to change my offloading decisions in order to avoid overheating problems than, for example, due to battery concerns or power limitations. So as a demonstration of this type of problems, we consider a very simple scenario. we only have one wearable, one service, and three possible ways to try and serve the requests of the service. So we can try a local service, and then we may overheat. We may offload through the edge through FR2 frequencies, for example, millimeter wave, but then we may have blockage, and then we may offload to the edge through FR1 frequencies, but then we have a higher cost. So there are three possible outcomes. Success, I succeed but I pay more than I should, and that would be the yellow outcome, or I fail because of overheating, and that would be the red one. So this is the distribution of the outcomes that we have seen for a prediction quality going from perfect prediction to no prediction to different level of imperfect prediction. So we have a jitter, and we change between 10 and 100%, and that's not very surprising. So if I have perfect prediction, then I never fail, of course. If I have a very lousy prediction, the opposite happens. The thing here is the red areas, so overheating, and the yellow areas, so I pay slightly more, are not the same. No, so I may not be happy if I pay more, but I will be very unhappy if I have services that fail because of overheating. So what can I do to avoid specifically overheating? What you do is you apply a safety margin to the to my prediction, and it does work in the sense that if I put a larger safety margin, I get less interrupted computations due to overheating, but I pay that with a larger number of unnecessary costly offloading. So there is no substitute for good predictions in this type of scenario. So in conclusion, in order for XR wearables and for metaverse-ish scenarios, you need device management, network management, resource allocation strategies which account for the unique characteristics of this scenario, which includes temperature and heat management. The main decision that we need to make in these type of scenarios is edge offloading. We are working on that, and I mentioned that very briefly. Of course, one thing that you need to put in the picture is when you go towards the higher frequencies, then you also have smart radio environments. We did try to buy, we are in the process of buying a pair of smart surfaces. They belong to the 85% of CNR money that was not spent yet. In the meantime, I'm very proud to show you our low-cost prototype. I don't know how clear the picture is. That is a cake dish. We can tell you that it successfully reflects sub-terahertz waves. So work is ongoing. And with that, I will thank you for your time and take any questions if there are. Thank you very much.
I have a couple of questions, actually. I really appreciate the new perspective of task offloading. That is a quite well investigated topic, but this new concept is very interesting. Maybe you can switch. I don't know if it is possible to switch, or you can comment the slide with the profile of the temperature. It is possible to predict this temperature value according to the type of task, the specific task that the wearable is performing, or not?
Thank you very much for the question. This is one of the most recent developments. So I'm very happy to tell you that the answer is yes, in the sense that the temperature that we were seeing there is basically the convolution of two components. One is the power, and that is the power at which the wearable operates directly depends upon our decisions. So if I offload more, then the power is at 1 and so on. The other component is something that characterizes that specific wearable, and that is something like an impulse an impulse response to a power surge. So the answer is yes, in the sense that one of the two terms of the convolution we decide, and the other we characterize based upon the specific wearable that we are using. So we are looking into embedding this type of convolution inside our system model.
Sorry.
The profile will change if the power level or the profile of the power level changes. So if the task is very complex, my power will stay higher for longer, and then the temperature will go higher, something like that.
Okay, another very quick question about the decision. The decision will be taken by the wearable or somehow centralized?
You are picking all the difficult questions here. Yes, so the answer is depends, in the sense that in the basic scenario, the wearable will make a decision on its own, in the sense that in the end, the network cannot really force the wearable to do something. But at the same time, in order for the offload to happen, there must be an edge support for us. So it is a negotiation with the network, which then more or less bounds the offloading fraction.
Okay. Thank you, Francesco.
Thank you very much.
So next speaker is Francesca Conserva. Francesca is a restart researcher at CNIT YLab. Now we will move to digital twin issues. The floor is yours.
Thank you so much, Claudia. Good afternoon, everyone. I'm very glad to be here today and that you are still here, actually. I won't cover actually technical aspects, unlike my previous colleagues, but rather today I would like to talk about the activity that we are currently carrying out in the context of the Grand Challenge 4, focused on the topic of a network digital twin. Let me say that this initiative was born a few months ago with the aim of putting together, let's say, all the effort, the study, the research carried out on the topic of network digital twin. So in principle, there's nothing new. However, what we, let's say, are trying to address is a crucial question. That's what is truly needed to implement, to build a network digital twin. So starting from all the insights of previous work, we are trying to identify potential gaps and find out possible strategies. So to begin with, well, let's say before start, let me try to remove any kind of misconception. Whenever I will mention NDT in the rest of this presentation, I want to refer to the digital twin in the sense of a replica of a single object, of a single asset, whether it is digital, physical, or both. But rather, I would refer to a complex system, so a system actually made of a lot of components, multiple components belonging to a telecommunication network. So by NDT, I will refer to, with NDT, I will refer to the virtual replica of a telecommunication network encompassing all network's elements, functions, and behavior. Let me spend a few words in order to justify the relevance of such a topic in the 6G landscape. Maybe nothing new for some of you, but let's say that this paradigm, the entity paradigm, for sure will provide us with a high level of automation efficiency from the viewpoint of the network management. We will have faster decision making as well as enhanced resource allocation, fault management, resilience. And last but not least, for sure, all these points will bring to, let's say, reduction in operational costs. So, as you may imagine, all these points is something that perfectly matches the current needs of telecom operators. And indeed, through these, let's say, items, through these features, they will be able to test and optimize their network strategies in a, let me say, risk-free manner, reducing, again, operational costs and enhancing efficiency. So, again, what we are currently doing is trying to put all together the efforts made in other, let's say, restart projects that focused on this topic of the network digital twin. Now, some of them are mostly, let's say, target some architectural aspects, while other, let me say, are pursuing a more application-driven approach. Anyway, trying to put together all these efforts, we're trying to, let's say, converge toward a unique direction. In particular, we're currently working on a white paper, okay, on the topic of network digital twin. And the analysis that we are currently carrying out started trying to identify what we think could be the possible enablers at a high level, let's say, that could unlock the power of the entity paradigm. For sure, what is crucial to begin with is the data availability. At any level, whatever granularity, data is something crucial, essential, mandatory to have a perfect, let's say, representation of reality. And then this data, of course, must be managed, must be processed, must be stored somehow, somewhere. And that's why we need a robust cloud infrastructure as well as cloud edge platform. At the same time, in order to make, let's say, this framework efficient, scalable, and usable, an approach that is the so-called SDN, the so-called software-defined networking approach would be, let's say, would be crucial. At the same time, the entity paradigm is something that must be continuously updated in order to reflect the dynamicity of the underlying network. And that's why what is crucial at the same time is the so-called development and operation approach, thanks to which we are able to continuously integrate, to continuously develop this paradigm. And at the end, of course, such a framework cannot exist without an orchestrator. So again, we need for a management and orchestration platform. Then we shifted the analysis toward, let's say, more architectural aspects. Here we have reported a possible implementation of a network digital twin architecture. In this case, this has been provided by, within the framework of ITT, Y.3090 document. This is a kind of architecture that is being deeply investigated by one of the projects in the Restart program. It's a kind of three-layer architecture where you can see at the bottom the physical layer, the physical network layer. On top of it, we have the nucleus of such a framework. We have the network digital twin layer where all the, let's say, functions that are stored, functions are tested, and on top of it, we have the network application layer. So a three-layer architecture. Now, what happens without going deeper into details is that imagine that we have the network application layer willing to provide the file network layer with some functions that could be related to network optimization rather than network management. So what happens is that either we test the framework in the green square, but then it's the network application layer that goes directly into the physical network layer. So the actuation comes from the network application layer, or, and that's why we talk about a dual closed loop mechanism, or the green square, so the true nucleus of this framework, the network digital twin layer, does, let's say, directly intervene on the physical network layer, so acting basically as an active entity, as an active element. Now, this is a possible implementation, a possible solution of the inner architecture of a network digital twin. But let's try to go further. Let's try to think, let's say, a more complex ecosystem where we don't have just a single network digital twin, because most probably this network digital twin could represent the entity of a telecommunication network of a specific mobile network operator. But think that we are willing to let this entity framework communicate with a parallel entity, maybe related to an industrial framework, to an industrial network. What we have realized is that from the viewpoint of the standardization is missing, there's a lack of a reference model allowing for such, let's say, cooperation. Because, of course, such a complex framework would, let's say, provide with a service, but still there's a lack of, let's say, interoperability provided by the SDO framework. And indeed, the last point of our analysis that we are carrying out and providing within this white paper is a kind of analysis going through each of these SDO, trying to identify possible, first of all, the focus area, but then we realize that each of them, though they strongly, let's say, deal with the topic of NDT, are basically, their analysis are limited to specific domain. So in an ecosystem that could be like a federated ecosystem of a number of network digital twin willing to cooperate to offer a higher level service, what is currently missing is a unified approach, is an alignment among these, let's say, organizations. And this is what we are currently trying to address in this activity. Of course, benefit from all these preliminary studies that have been done in the other project within the Restart program. Having the presence in our working group of some colleagues that act as 3GPP delegates, some colleagues from FiberCop, for example, for us this is an opportunity, because from our small reality somehow, this could be a way to convey this message, okay, to those tables. So, thank you for your attention. This concludes my presentation.
Schedule, so we have time for a couple of questions. Do you have any question for Francesca? Comments for her? It's very hard to be here at this time.
We are tired.
Okay. Actually, you provided a very nice overview of the network digital twin ecosystem, and you pose a very daunting challenge, this cross-domain cooperation.
Yeah, let me say that whoever wants to join the Grand Challenge, it's a true Grand Challenge. So
yeah, really,
you are welcome to join us.
I don't know if you can, if the leader of the Grand Challenge allows you, but you can spoil something about the solution that you plan to provide in order to address this cross-domain interoperability. I mean, it is a kind of eastbound, westbound interface to be redefined. Will be some REST interface somehow customized or something else?
For sure, this is something that must come from the, let's say, SDO framework. What we can do is to, let's say, try to convey this message by providing maybe, by bringing to those tables some use cases, okay? In such a way they are even more aware on what is currently needed and why this, let's say, need for interoperability is actually needed. For sure, the contribution process is not a straightforward task, but I strongly believe that by following, let's say, a rigorous methodology, something, let's say, can be brought, and maybe this message can be, let's say, worldwide somehow.
Okay, thank you. So the service-driven approach, the use case-driven approach could support this cross-domain orchestration and interoperability. Okay, thank you once again. Let's thank once again Francesca. So the last but not the least speaker is Eugenio Moro. Eugenio is an assistant professor at Politecnico di Milano. So we will move to a more practical view of digital twin.
Thank you. Okay, thank you. And you can read the title of my presentation today. It looks extremely complicated. Can I have the pointer? It's not. I have to say it's extremely simple, and I can spoil it to you in a few slides, and this is what I'm going to do it right now. It's a full stack multi-RAT simulation with ray tracing in the loop. But what does it mean? So we started from the background. A digital twin of a communication network requires an engine that's an extremely accurate simulation of the physical object. In our case, it's a network, it's a communication network. We have many tools, we use them during research, but they are actually not really well designed to be a full stack simulator, extremely realistic, high fidelity simulator of a real network. And why don't we integrate NS3, which works very well for something, and a ray tracer, Shauna RT from NVIDIA, that works very well for some other reasons, and finally build a tool that we are satisfied with, and on top of which we can start running a digital twin. And this is what we did, and that's all. And these are the contributions of today's presentation from me. And to me, it looks extremely simple, and we thought, this is so simple, nobody tried it, we are surprised. And somebody actually did that, because then we published it on LinkedIn. We prepared a preprint, we put it on LinkedIn, and turns out somebody else did something similar 2 days before we did that. But none of the others are from Restart, so you know who you should support, okay? Thank you. Anyway, let's move on. The presentation could end here, but I still have more than 7 minutes. Okay, so this is a collection of definitions for digital twins. And I've highlighted basically what I want to convey with this slide here is that we have different meanings for digital twins. We might have different meanings for network digital twins, but what we need, it's a core requirement, very precise simulation of the entire network. And here comes the problem. So anyway, this is a core requirement for everybody. Everybody agrees with that. We have a lot of tools to make simulations. I know some of them. My other co-authors swear that they exist. I never heard some of them, but the philosophy, I'm pretty sure the philosophy behind every simulator here, it's that one on the right. A simulator needs to be as simple as possible, but no simpler than that. And they're served extremely well. When you do research, you want to focus on a single feature of the network, and then abstract everything else, everything that you can abstract that works well. For research purposes. For digital twins, no, not really. We need a full stack simulation that's really, really accurate at any kind of layer, and we don't want any abstraction, right? That's the concept behind digital twin. So we took 2 of them that you might know. They are extremely famous. Most famous one is NS3. It's a network simulator, and everybody uses that for research. And we took NVIDIA's Shauna, which is an open source ray tracer that can be accelerated through GPUs. And we wanted to put them together. And why? Shauna RT, it's pretty good as a physical layer simulator and as a propagation study environment. It's a ray tracer, but it's actually also recently implementing the layer 1 of 5GNR. But there's no MAC, GTP to RLC end application, nothing like that. It's a link-to-link simulation, if you want to call it like that. But primarily, it's a ray tracer. NS3, on the other hand, it's pretty capable, starting from the MAC, GTP to RLC, everything in an application. The problem is that the physical layer is stochastic, and there's no real propagation. Well, I mean, there's a 50, 100 people here, so you might know an S3 module that's actually doing ray tracing, not that as complex as Shonna, I'm pretty sure about that. But there's no single solution in NS3. The channel model, the preferred channel model in NS3 is stochastic, and that doesn't work with ray tracing, and this is what I'm gonna show pretty soon. By the way, what we want, something like that. The physical layer and the propagation of Shonna with the higher layer of NS3, and that would be a really powerful tool. In our opinion, it turns out it is. So we try to implement that, and we said since we are working with two pieces of software that are separated, why don't we run them in a way such that NS3 can run on any machine? The physical layer is computationally intensive, but if we take the physical layer out of NS3, that's pretty doable to run even on a laptop. And NVIDIA Shonna can be accelerated through GPUs. So let's disaggregate this digital twin tool. Let's put the GPU in a central, Shonna in a central GPU farm with a lot of power, and we might pay for it as soon as we need it, and we leave NS3 in our machine. And this is actually what we did. So we have two campuses in Politecnico di Milano, and we have NS3 running in a campus, and there's a server farm in another campus that's running Shonna, and that works very well. How did we do that? We have a UDP tunnel between Shonna and NS3, and basically the lower layer, the physical layer functions callbacks from NS3 are not called inside the software, but everything is encapsulated in a UDP packet with some communication protocol design, such that we ask Shonna RT for the propagation computation, and Shonna does its job and sends back the information to NS3. And from the upper layer, this is transparent, and from the point of view of Shonna RT, that's also transparent. So that was the scenario, that was the setup, and this is the scenario where we tried it. We focused on a vehicular scenario because we thought it was this is one of the hardest simulation scenarios for traditional simulators, because the mobility is pretty high, and stochastic channels are, well, they are stochastics. They don't deal with mobility very well. They don't deal with high frequency very well because blockages are probabilistic. So this is what we did. We have 20 vehicles, they're exchanging messages. And we have a multi-stack scenario where we want to see what's the performance of the entire system in these three technologies and in a multi-band scenario in these three frequencies, which, by the way, I'll show you right now, it's a mess in NS3. Because stochastic channels, well, they depend on the technology. That's surprising, right? The propagation environment is the same if you're using 4G or 5G. But there have been changes in the years in propagation models, and this is what we have. We have, for the same propagation frequency, different stochastic channels that are by default in NS3, and they produce different results. And these are the red lines. And 802.11p, it's a simple log normal. No shadowing and no line of sight. And while we have some probabilistic line of sight in LTE and 5GNR. What is the impact of this difference that we see from the propagation layer, from the propagation point of view, on system level KPIs? So we built a synthetic KPI, which is this PRDR, which is how much the stock NS3 disagrees with our new NS3 enhanced by Shonna. And we have up to 64 maximum discrepancy. It means that these two simulator tools, they disagree 64% of the time at most. And here we close the circle, because we come back to the point that I was mentioning at the beginning. If we need for a digital twin an extremely precise simulation tool, we cannot have 64% mismatch with something more realistic, which, by the way, it's more realistic than a stochastic propagation model. It's not the best. The RT needs to be calibrated with the real scenario. So we don't really have a real baseline. But as far as we can see right now, the paradigm needs to change. And this is, again, I'm closing the circle and coming back to my hypothesis. We cannot have a digital twin if we don't have this kind of tools. And this is the proof. And by the way, this is for multi-RAT, and this is for multi-band. And we see that the discrepancy, the disagreement ratio, it goes higher with higher frequencies, which are the ones that we are going to use in the future, that we are starting to use right now. And those are the ones that we possibly want to study and include in a digital twin, because complexity increases, and we need a digital twin to manage it. At the end of the day, that's why we do it, okay? That concludes my presentation. We also thought about some research directions. So we need to deal with problems in the architecture. This is a disaggregated system. It works well, it's supposed to work well, but there's some research that we need to do that. The ray tracing information that we use right now in Sionna and S3, it's not as complete as it could be. We are not using information on Doppler, on many things, okay? I don't want to be very specific here. Hardware acceleration, we have to understand what's the role of hardware acceleration in this case. A digital twin, it's probably not gonna be a digital twin of just this really small scenario. It's gonna be large as a city. So we need powerful GPUs, and we need large data centers, and we really need, we foresee that hardware acceleration is going to be very important in the future. And the entire PHY offloading, it's also something that we plan to do. Because as I mentioned at the beginning, Sionna RT, it's actually not doing only RT, but it's implementing the entire physical layer. So we can manage MIMO, we can actually add real MIMO capabilities to NS3, which were not there. We can play with waveforms. We can do all those sort of things that we couldn't do before, and we can do that accelerated by a GPU. So the potential is incredible. If you want to have a look at a live demo, we are at WCNC in Milan. We have submitted, let's say, a preliminary paper on this to a workshop in Infracom. We have a PhD student, finger crossed, that's going to work on this, Roberto, which is one of the authors. We really are grateful to him. We are trying to coordinate with the developers of Sionna. One of the authors on the first slide, if you caught it, it's Jakob Hoydis from NVIDIA. We don't want to, repeat efforts, and we are really grateful to him as well. And last point, we're trying to go forward with full integration for the vehicle case in collaboration with Politecnico di Torino, which are providing us MS Vanet, which if you don't know what it is, it's extremely well done simulation framework that works on top of NS3, and we would like to make an entire digital twin, at least the engine part of the digital twin, also with that. That's all, and thank you.
Any question from the audience? Comments, curiosities? Actually, we have one question. I have a couple of questions as well.
So I hope to not say silly things, but it's a very long time I don't write NS3 code. So my question is, if I'm not wrong, NS goes packet by packet. So how long it takes to send the query to NVIDIA and get back the answer packet by packet? So the first question is how much complexity is, how much time does it take the simulation? Second one, you showed the measure just on single transmission, just for a sake of presentation, but stochastic is stochastic, so you have to do the comparison on multiple transmission. So on how many transmission have you got that results?
All good questions. For the first one, it's well, the delay between the callback that's intercepted by the additional code that we put in S3 and the moment when we get back the answer, it depends on the transmission delay of the packet, right? So it's probably going to be in the same data center. I think that's negligible, and by how much SeanRT takes to compute, or actually to give back the answer. And the point is that I don't have a slide showing these, but SeanRT has a map of, well, a mesh of the scenario and a map of all the transmitter and, I mean, actually one transmitter and all the receiving points. Most of the answers are answered by cache. The software, it's actually not just asking for the channel, but updating SeanRT whenever something moves in the scenario. That requires new computation by SeanRT, otherwise it's cached, okay? And that might take some time, but it's also extremely efficient software. I still don't have a slide for this, but one of my co-authors actually did a study, Francesco, maybe we can talk about this offline, and they found out that it's one of the most efficient, if not the most efficient ray tracers. So provided that we need this kind of solution, as of today, we believe the Sionna is minimizing the end-to-end delay in the callback loop. That's all I can say. For the second question, it was a good question also. That's just one realization of the channel, of course. And Roberto, which produced the result, here is showing, we are actually showing just one realization. I think we have seen some discrepancies also when we take an average over a long time. But that's a valid question. My opinion is that if you have to take a decision now, you have to have an instantaneous reproduction of the physical object, meaning that I cannot wait 5 minutes such that my averages of the stochastic channel converge to what it's supposed to be the real channel. I cannot do that. I need an answer right now, and if I'm going to use an answer right now, I'm going to look at one realization if I use stochastic NS3, and that's never going to be accurate.
Okay, thank you. Any other question, comment? Okay, I guess that we can conclude this session. Thank you for attending it. Thanks once again all the speakers.
We have one more, don't run away, we have one more session, which is on optical networks, and the chairperson will be Guido Meyer. Guido?
Yes, thank you very much. Thank you for, I hope not too many of you is fleeing to the hotels. Before starting the sessions, I would like just quickly to make this announcement for this conference that is HPSR 2025. It will be in Osaka, and of course it's very much related to the topics also of this question. There is an extension of the deadline, so as general co-chair of this conference, I invite you to submit papers. Okay, so thanks, and now let's start the session. This session is dedicated to optical networks. And we will have 3 talks that are very visionary on aspects that are very relevant in this area. And the first one is the application of federated learning for failure localization and optical networks by MEM. MEM, thanks. So, please.
Okay. Hi, everybody. The presentation should be Ibrahimi. Okay. So the title of the presentation is The Application of Federated Learning for Failure Localization in Optical Networks. First, I would like to provide some context of the project that the work has been developed on. So it's part of the Rigoletto project that Piero mentioned today. It covers all 3 sections of optical networks. And on top of it, there is an AI-based network orchestrator, which is composed of many different building blocks. And among these building blocks, the one that I will focus on, and the one as part of which this work has been developed, is the failure detection, classification, and localization. So going to optical networks, and this does not work. work. Non va. But I cannot. So yeah, there's flashing, but it's not moving forward. Okay, so talking about failures in optical networks, obviously there are hardware failures and soft failures. When we talk about soft failures, the idea is that there's degradation over time, and we have some. I'm not touching it. Okay. I think I have enough skills to know how to run this, so I'm pretty sure I'm not. Yeah? I cannot. Perfect. On and off. Okay. If you can just go with the slides, at least I can talk on top of it. We restart? I mean, it fits the theme of the day. Well, we were talking over dinner last night that it's impossible to restart the PC now without thinking about restart, so. It freezes here for some reason. Ma sto andando avanti, ma non va. Parti dal slide numero 3, forse va. Go to 4. It's okay. Go to 4. I can. Just go to 4. We can start from number 4. It's okay. Okay, anyway. Okay, so going back. So I'm talking about failures in optical networks. And they might differ on the type, but also on the location. So depending on where the failure happens, you might have different anomalies that appear. And usually the way to solve this is through machine learning. And a valid question is this just another ML paper? But first, before going to the solution, allow me to provide some context. And the context pertains the concept of disaggregation in optical networks. So in today's world, most of the existing optical networks are not disaggregated, meaning that there's a single entity that manages them. There's the same vendor which might be providing the equipment for a given part of the network. Instead, there's the other side of the medal, which is fully disaggregation, in which we have equipment from different vendors and also different entities that might be managing the different parts. Then there is the middle ground, which is partial disaggregation, which means that an operator might be managing a part of the network, and then there's other operators that manage other parts of the network. However, mixing these two, failure management and disaggregation, requires and raises concerns on data confidentiality. And the request, the research question that we posed is if it's possible to have a solution which is able to solve this problem of failure localization, but at the same time to enhance issues on data sharing. Of course, the solution lies on federated learning, as I anticipated in the title. However, there are different flavors of federated learning. So in cases in which we are dealing with monolithic scenarios, which are not disaggregated, the solution is usually based or is called horizontal federated learning. This means that the features, here denoted as F, are the same among the different samples that might be collected, and these are shared in a confidential way with the server entity. On the other side, which is more, let's say, the direction that we are looking into, is the vertical federated learning. Here, the idea is that the features that you have in different parts of the network are different. Therefore, the model, which has to be shared and learned by a central entity, has to account all for the different features. How, from a point of view of the methodology, how we can solve this? There's basically two main flavors. There's the one based on neural networks and the one which is based on decision trees. And of course, I'm not going to go into the details. We used the data sets which were gathered from two different test beds. One was a collaboration with NICT in Japan, where we collected data from different parts of the network. And the other one in collaboration with Sant'Anna in Pisa. The difference here is that in the second one, we collect information also in the middle points at the amplifiers. And looking at the different ways how federated learning can be applied in these two test beds, we have, for the case of Sant'Anna, the centralized scenario, which is the baseline, meaning that there is an operator which has a full view of the system and can gather all the data from all the different points. On the other side, there is the two-operator scenario, meaning that there's an operator that has access and can gather data from the amplifiers, and then there is another operator which can gather data at the receiver. In a similar way, for the case of the NICT dataset, there is always the baseline, which means that there is an operator which has a full view of the system and can gather data from all the different points, or the scenarios in which there are two operators or three operators which are able to gather features from different sections or different parts of the network. Now, let's see some numbers. So I'm showing here three different colors. The central one is the baseline, in which the operator has a full view of the system. In this case, to solve the failure localization problem, the F1 score reaches up to 87%. We see that with the federated learning approaches, the F1 score is slightly lower, but what we can learn from this is that we are willing to pay a penalty of 2-3% at the benefit of having an enhanced confidentiality. If instead we do not share the data and everybody just works for his own interest, let's say, then we see that the performance is degraded significantly. In the same way, also for the data set of Sant'Anna, we see that since we are gathering more data, the accuracy for the localization is significantly higher. However, the takeaways still stand because we are paying a penalty of 2-3% at the benefit of having enhanced data confidentiality. To conclude, federated learning-based solutions can enhance confidentiality with some penalty 2-3% on accuracy. There are some challenges that need to be addressed. First and foremost is the data availability, meaning that operators have to be willing to share the data. And the application of federated learning by itself does not guarantee a solution which is privacy preserving, so there are other approaches that could be used to enhance it. And our goal is to make available the data sets that we have to address the other challenge. And of course, since I know open fiber is going to present today. We are open to collaborations as part of this work has been also identified and submitted as part of Mission 3. Thanks for your attention, and I'm open to questions.
Questions for the audience? Okay, I have one question. What kind of failures can you detect in this case with this technique?
So since this is related to soft failures, it might be a degradation on the performance of an amplifier, which means that not necessarily you're not decoding the information that you get, but over time you see a degradation, meaning that at a certain moment in time you might arrive in a point in which you are not able to decode the signal that you are transmitting.
Okay, so it's not very effective against unpredictable. I mean,
no, I think the word in itself, unpredictable, I think answers the concern. Yeah.
Okay. Any other questions? Okay. If not, thank you again.
Thank you.
Dr. Ibrahim, and Massimo Tornatore is the next speaker, and also in this case we will have a visionary talk about optical networks again. This also addresses a question that has been already raised in previous talks, so the hollow core fibers. Thank you, Massimo.
Thank you, Guido. Good afternoon, everybody. Almost good evening, actually. So already this morning we mentioned hollow core fiber a couple of times. The objective, the goal of the presentation is to provide you three tangible applications, use cases for hollow core fibers in future optical transport networks. I'll start with the basics. I don't assume that hollow core fiber is a concept universally known by the audience. We all know what is a fiber, right? It's a filament of glass where the core of the glass has a higher refraction index than the outer part, the cladding. Now, this difference in refraction index enables what we call total reflection. So basically, the signal transfer propagates thanks to this physical principle. In the hollow core fiber, which we see here on the side, the core is hollow, meaning that is empty, is vacuum. And so the propagation cannot happen with total reflection because the refraction index of the air is the lowest one. And the only thing we can do is to find other waveguide-oriented physics principle properties to do this propagation. Some of the names can be anti-resonance. We're not going to get into the details. It is, though, quite evident that if you propagate your signal in vacuum, you have at least these three advantages. You have less latency, because you go faster, light goes faster in vacuum. You have lower nonlinearities because you don't go through glass, so you don't suffer the nonlinearities of glass. And you have wider bands because you're not confined into the bands that work well in glass. This is kind of intuitive. Less intuitive is the fact that also attenuation very recently has become one of the advantages of hollow core fibers. So up to a few years ago, you see it was 1.3 dB per kilometers. The typical attenuation factor of a standard fiber is 0.2, which was reached in 2021. Nowadays, we're talking about 0.11, half of it, and even, in principle, we can get to 0.05. So even attenuation is becoming an interesting aspect of hollow core fiber. What does it mean, this in terms of throughput? I usually refer to this famous graph proposed by Professor Poggiolini a couple of years ago, in which you can see the isometric curves. Those curves represent, the number on the curves represent how much more throughput you have in a hollow core fiber than in a standard fiber, right? So 4 means I have 4 times more throughput. And you can see on the x-axis the attenuation coefficient, which goes down up to 0.05, as I said before. On the other axis, you have the launch power. Since you don't have nonlinearities, now you can go high with the launch power. And you can see that there is a very large space in the plane where hollow core fiber wins. Basically, it's better than traditional fiber in terms of throughput. So this following slide basically recollects all these gains. It's a courtesy of Francesco Poletti, who's another very important and pioneering researcher in this area. You can see low latency, low nonlinearity, wide bandwidth, ultra low loss. I use this slide to summarize the 3 use cases that I want to discuss today. So the first one is low latency. We're going to see how low latency is one of the enablers of this effect, which I'm going to comment, this use case, which is the edge data center consolidation. Then we talk about ultra low loss, already mentioned, and especially combined with low nonlinearity enables low power consumption. So energy efficiency is another aspect that we can consider when we talk about deploying hollow-core fibers. And finally, the larger bandwidth is also enabler in terms of capacity scaling. I know it's a generic term, I'm going to define it a bit better later. All these works have been actually conducted by Giovanni Sticca, who's not present here because he's a Restart-funded PhD student who's now visiting a group abroad, so I decided to present it myself and leave him alone in London and enjoying his time with the other group. So let's start with the first use case. I'm afraid something already seen is happening again. This is always slide number 4. Maybe there's a pattern here. Can we do something? It's the group, right? It's there's another pattern here. It's not only slide 4, it's also we decided to put big pictures in slide number 4. Actually, I think they skipped indeed the slide, which is fine. So let me reorganize a little bit the talk around the slide that is missing. Okay, this was the one that is missing. So we said 3 use cases, edge data center consolidation, energy efficiency, and capacity scaling. Let's start with the edge data center consolidation. We already discussed that there are various reasons why hollow-core fibers is an enabler. I'll start with a very simple example, which is not actually showing. It's so simple that it's not showing. So imagine here you have a metro network in which you have clients at the edge and you have data centers in the metro network. And then you want to have services at low latency between the clients and the data center in the metro network. This would be the perfect moment it appears, but it's not appearing yet. So of course, if you have in your metro network some low latency services, the low latency property of the hollow-core fiber would allow you to have less data centers. I was hoping to support this with some. It's fine, I think, yeah, we can restart from this one, which is the next one. So what I was saying, we can enable consolidation of data centers. Let's see it on a use case, on a case study. The specific case study there is a topology inspired by Telecom Italia for the metropolitan region of Milan. Imagine a square of 14 by 14 kilometers, and you have these 52 nodes. And you have users at the edge that want to access services with latencies which go from the budget which is allowed to the optical network for the latency goes from 100 microseconds to 400 microseconds. Then in such a network you need a number of edge data center which goes from 30 down to 6 if you have standard fibers available. Now the interesting point is that even if you just upgrade, let's say 2 or 3 of those 52 fibers, so 4% of the fibers, you are decreasing the number of data center of a reasonable percentage up to the point that you basically saturated 20%. So selective deployment of hollow-core fibers in a latency-constrained scenario, not 100% greenfield deployment, but selective brownfield deployment can already lead to significant savings in terms of, in this case, CapEx for edge data center deployment. And it's not only decrease of data centers, it's also decrease on number of transponder and increase in terms of throughput. Second use case is energy efficiency. I'll flash quickly again the same figure that I've shown at the beginning, where you can see on the y-axis the launch power that it can get very high, and especially in hollow-core fiber, the gains for high launch powers are specifically higher. Now the question that raises is, if this is a technology that benefits from high launch power, are we still being energy efficient, or are we going in a direction when energy consumption increases? Of course, this is a rhetorical question. We go towards energy efficiency, and I can show it with a very simple example. Imagine a link with 320 kilometers, amplified, 3 times with 3 amplifiers every 80 kilometers. We have a total power for amplification of 36 watts. Thanks to the higher launch power, thanks to the lower attenuation factor, we can serve the same line with only 1 amplifier with the obvious decrease in terms of energy efficiency. Of course, this is an increase in terms of energy efficiency. Of course, this is just one example on a very specific and simple scenario. If we go on a larger continental size network like this one, the gains become particularly interesting. So here I'm basically plotting the improvement of hollow-core fibers with respect to standard fibers as a function of the launch power which I'm admitted to use. Okay, so I increase the launch power, and I can see that throughput is always, of course, higher in hollow-core fiber. That's what we said at the beginning of the presentation. But also power consumption for amplification is very beneficial at the beginning of the graph. And also the number of transponders are more or less 50%, in a number of 50% less with respect to standard fibers. So here we can identify a soft spot around 30 dBm of launch power, in which we are basically maximizing throughput, minimizing amplification power, and minimizing power for transponders. Finally, capacity scaling. What I mean with capacity scaling is the most obvious interpretation. We have initially one fiber, the continuous lines in blue and in red. Traffic grows, we need to add new fibers. We have different choices to be done. We can scale the capacity of the link from one fiber to another fiber using another standard fiber. This is what we call N by SSMFC. SSMF is the standard fiber. So N standard fibers operated in C bands, N standard fibers operated with a new technology, which is multiband, and it's called C plus L. So basically you double the capacity of your fiber. Or you can scale your network adding to the original standard fiber a second hollow-core fiber. And we call these scenarios hybrid C, so hollow-core fibers operated in C-band, and hybrid C+L, hollow-core fibers operated in C+L band. Just a quick comment. I'm staying very high level. It's also very late, so I think it was a good idea. But for all these problems, we had to develop network flow optimization problems in order to place the hollow-core fibers properly. I'm not going through any of those. I'm only concentrated on the problem statement and on the results. So regarding the results, here I'm plotting the throughput for one standard fiber, 160 terabit per second. For a C+L operated standard fiber, so a fiber with 2 bands used, we are going actually close to 200 terabit per second. 2 C-band fibers up to almost 400. 2 C+L fibers, we get up to 500. And even as a reference, I'm placing 4 fibers, which is the dotted green line. Now I'm adding to the graph the situation where I include also hollow-core fiber. This is a bit complicated, but you can see from the graph that hollow-core fiber basically allows to scale, again, the capacity of the network by only selective placement. Let's make an example with 50% of deployment of hollow-core fibers, so only 50% of the links have been upgraded. I achieve exactly the same performance of having 2 standard fibers everywhere into the network. Okay, this is just an example that can be taken from this graph. For 100%, we basically get in C+L a performance which is almost close to 4 fibers in standard C-band. So concluding, what I wanted to comment today was the fact that after years of investigation on the propagation properties of the hollow-core fibers, it's time to look also at possible use cases, applications of hollow-core fibers in future optical networks. We identified 3. We went through case studies for these 3 use cases. Reduction of edge data centers, especially in metro latency-constrained network. And we've seen that a selective choice of few locations for hollow-core fiber already enable good savings. Similarly, for energy efficiency, we've seen that we can achieve significant savings both in terms of amplification power and transponder power. And also as a technology to scale the capacity of the networks, selective deployment leads to very interesting savings with respect to standard fibers. Thank you very much for your attention.
Thank you very much. We have time for questions. Massimo has been very, despite the problems with the projectors.
Can you say it again? So the cost of manufacturing of these fibers is a well-preserved secret, a very well-preserved secret. We talked with the main producers today, but they don't share this information. Roughly, and let's say confidentially, they're talking about in 5 years, the cost is 100 times more than the current cost of fibers. But the current cost of fiber is small. It's not, I mean, you don't design your network based on the cost of the fiber. There are other reasons, right? So even 100% more is not changing so much your decisions. So the cost aspect might be solved in the future. Regarding the other aspect of the question, the deployment, they're starting to deploy. So there are deployments in China, and there are deployments by Microsoft in their network, especially for data centers like regional data centers for which savings, as I was mentioning before, hundreds of microseconds makes a difference. For example, for training of machine learning models, it's something that is already been deployed.
Yeah. Okay. So the cost probably is balanced by the gain that you can have on energy and throughput on reducing data center and something like that.
I mean, if there is a big cost driver, I'm thinking about financial transactions, right? For years, they used microwave links dedicated to financial transactions to gain the latency. So this is another technology that can do the same. Yeah. Thank you.
Thank you, very interesting. I was wondering about the mechanical robustness, and also does this kind of fiber have the same bending radium is comparable with standard fibers?
Not yet, as far as I know. I know that is a known problem on which people are working, and the current deployments being in confined environments somehow bypass this problem, right? Within a data center or on a specific protected line, it's probably not a big problem, of course. If you want to use it for access, probably we're not still there.
Any other question? I have just one additional question that follows the previous one. Do you have to replace the amplifiers if you...
Yeah, very good question. No. I mean, you have to add the amplifiers for that fiber, but the technology of EDFAs that is used for classical fibers can be reused for hollow core, which is one of the reasons why our study was on C and L band. Because probably those will be the first bands to be used because you can reuse the amplifiers which are already available.
Okay. Thank you very much. Any other question? Okay, thanks, Massimo.
Thank you.
And now we have the final talk. Sorry, my position. Okay, so the final talk is from Open Fiber. Okay. And Marianna
Hovsepian.
Sorry, my pronunciation.
Good evening, everyone. I'm Marianna Hovsepian from Open Fiber. I'm transport network engineer. And today I will present the concept network sensing, sustainable environmental monitoring, distributed with distributed optical fibers. We are studying this concept within the focused project SensingNet that is governed by Open Fiber, let's say. Just a quick overview of the project. I will not spend too much time, I promise, taking into account the hour. Just to explain the scope of the project. SensingNet aims to develop solutions, services for monitoring of environmental infrastructure, environmental monitoring, let's say, using new technologies, sensing technologies, by integrating these technologies within the already existing infrastructure, because sensing technologies exist from different years, and there are a lot of commercial already available hardwares and very efficient. But the real innovation within this project is to integrate these technologies within already existing fibers infrastructure, like an Open Fiber. The project, I can say that it is, we will have a 360-degree overview for this concept, because we are going to study from the theoretical point of view, from the standards. So we are going to study the coexistence of the data signals and the sensing signals in order to guarantee a correct transmission as for the sensing data, as for the final client signal data. And also because there is a lack of the information for this topic because it's very fresh. Interferometric method, there are a lot of technological solutions, but not integration within the existing infrastructure. And we would like to put a piece of puzzle within a puzzle of 100 pieces because it's very important from the telecommunication point of view. We already talked about the reduction of the cost, sustainability point of view, etc. And then going to, I can change, I don't know. Okay. And then we are going to realize some POCs, proof of concept, on the real infrastructure of open fiber, and the work is ongoing, let's say. Within this project, we are going to use different technological solutions for different use cases, for enabling the monitoring of earthquakes, monitoring of the infrastructure, using the passive optical network, access network infrastructure. On the vertical, building monitoring, or road monitoring, or even the network monitoring itself for the intrusion use case, for example. The main technologies that we are studying in this project is the interferometric method, in-band Michelson interferometric method, ultra-stable laser interferometric method, and the state of the polarization telemetry method, let's say, is just a state of the polarization of the signal of the transmitted data that is available in our network. Is the same problem? I don't know. Ah, no, okay. I will just go on for saving time. I will just go on the slide 5, just to take a view what we have done until now from standards and requirements point of view. So on the left side, you can, on the right side, from your side, you can see that why I said 360 degree of view, because we started from the theoretical analysis to go to simulation, numerical simulations, to go to experimental tests in the laboratory, and at the end, in-field trial. So we will cover all the aspects from this point of view. And at the initial phase, we have done a study with help of Polytechnic of Turin and Polytechnic of Milan, the study of the standards used in the optical network infrastructure, starting from the access networks to the metro network, and also requirements, technical requirements of the sensing technologies, as for the interferometric method, as for the DAS system, distributed acoustic system. And going very quickly for this part, from the to generate, let's say, a system for numerical analysis, the study were concentrated on generating several channels and in between putting the sensing signal in order to see the interference of the sensing signal to the data signal and vice versa. So they are generated through scenarios using 3 special channel spacing between sensing and data signals and different symbol rates in order to evaluate the degradation of these signals. And for the interferometric method, we have obtained results that it is, if not 100%, 99.9% is compatible, because it is using interferometric method using the ITOT standards channels, and it's just to dedicate one channel within wavelength division multiplexing system used in our architecture, but we need to let's say be careful about the power that we are emitting into the systems. the other study is concentrated numerical simulations on the DAS system, that distributed acoustic system that we know is used to propagate in a dedicated dark fiber, let's say, because of high power it is injecting into the fiber that is interfering onto the optical channels. And studies were concentrating also in this case to generate different channels near to the sensing channel and to see how is varying the SNR value of the data channel depending on the peak power of the system. On the left side you can see that the SNR is quite stable of the channel until arriving at the higher powered higher than 20 dBm, and the degradation is notable, especially for the channel spacing of 50 gigahertz and narrow bandwidth. So, but still, the let's say the signal is possible to recover after phase recovery systems. Moving on with the experimental results, in the Turin city, underground fiber is were tested by combining data channel and the DAS channel, and the various perturbations were noticed on the city conditions. Let's say it is very there's a lot of noise considering the movements of the city, the cars, etc. But they were able to identify the degradation of the optical fiber channel due to the DAS technology. And on the left side, you can see the bare versus SNR diagram that as well. Also, in this case, it is shown that the SNR is, the bare is degrading by the power, peak power of the DAS system is getting higher. So the conclusion from this study, from the study of point of view, is that the coexistence of sensing technological solutions within data signal is possible, but we need to be pay attention to the peak power of these solutions. Okay, moving on the field trial part. We already have done some field trials in San Donato Milanese area on the passive optical network FTTH infrastructure of open fiber by integrating the in-band Michelson interferometer into our network. And we studied the use case of intrusion detection, intrusion monitoring, let's say, on the cabinet that is available in whole of Italy. And also with this technology, we are going to monitor, enable the monitoring of infrastructure, of building monitoring, the state of the building, the road monitoring, and we will see the results in the next slide. Another use case that we will enable, let's say we will try to build in our network, is the earthquake detection by introducing the ultra-stable interferometric method and state of the polarization that I mentioned already before. But for this use case, it is very important to notice that with the cascade call, we welcome into the working group and let's say seismic expert that is INGV is responsible of the seismic system in all the Italy. an expert that can say, okay, it's a seismic event or not, because with this system you are able to see the vibration, because fiber is an ear that listening everything, but to detect and identify which is the earthquake signal, which is the infrastructure stability, which is the road condition, let's say the monitoring. We need to understand if the data that we are receiving is related to earthquake signal, related to infrastructure stability one, and etc. So the activity with this work for this use case are going on, and we will build the field trial in this year. Okay, another use case is always the same use case, earthquake monitoring, but using another technology. So we'll be able also to say, okay, this technology is able to detect earthquake, or this technology is maybe better to use for another monitoring system, road monitoring, etc. We can compare two technologies for the same use case, or different technology, the same technology for different use cases. This is the field trial that we enabled in San Donato Milanese area, of Opera, of Open Fiber. We install Coherencia is a startup that is collaborating with Polytechnic of Milan, that is providing the laser. It's a commercial laser, but the processing are doing and by dedicating on the spare fiber, the already deployed FTTH infrastructure fiber, with the length of around 7 kilometers, we used interferometric method to arrive until the building of a connected building with the final users. And used just a standard ITUT channel on 15 nanometers channel. By generating the vibrations, let's say, on the fiber, near to the fiber, near to the cabinet, you can see that by knocking, or by continuous knock, or by single knock, you can see that there is a response to the system of this perturbation on the fiber. So it can be enabler of the early warning from the act of vandalism on the network infrastructure as well. Okay, this is just some different ways of this to generate artificial perturbation on the fiber by electrical scooter, by hammer strike, by just walking, pedestrian walk, etc. Or even a single jump, single pike of the. You can see a single pack of the signal. It is able to detect the perturbation on the vibrations around the fiber. So we can consider as the same fiber is used as for the cabinet intrusion or network infrastructure monitoring as for the road monitoring, because in this way, if it is near to the fiber, you are able to see the movement around the fiber. By integrating the maybe machine learning algorithms or artificial intelligence algorithms that will be developed maybe later, we will be able to differentiate automatically which is the jump, which is the walk, which is the scooter, etc. So the main topic of today is network sensing. The fiber sensing is a concept exists from several years, but we would like to introduce a new concept, network sensing, because is a sustainable environmental monitoring, because with the single fiber, as I showed before, we saw that we are able to monitor earthquakes. We will be able to monitor a network itself and infrastructure, road, bridges, landslides, a lot of use cases that can be enabled with the same single or two fibers, let's say, that is deployed in all Italian territory. With this, I will ask, can we, let's say, replace the already existing traditional systems with the network sensing? I would rather say no, we are going to integrate in order to guarantee more efficient monitoring systems by reducing the cost and guaranteeing major geographical coverage, low latency, and high capacity. Because, for example, the seismic stations, now you can see it seems there's a lot of points, but it's because of the photo, it's a little bit tricky because they are giant icons. And if you zoom in, you can see that the seismic stations, traditional seismic stations, they are point stations. And they are localized near the events that are very, they are under monitoring of the, from the INGV. But to guarantee more coverage, it is very useful to use this kind of technology for a future monitoring system, let's say. And why network sensing is sustainable? Because we are going to improve monitoring effectiveness by reducing, by having low maintenance, energy saving, integration within the existing infrastructure, reuse, and a reduction of electrical waste. And with this, I would conclude the talk. Thank you.
Thank you very much. Time for questions. Oh, I have one curiosity. In the solution where you are using passive optical networks, I didn't understand if the sensing fiber is the same that you are using for the splitter or is an additional one.
Okay, the idea is to use the sensing in the PON architecture. We use interferometric method. It's an in-band Michelson interferometer that needs to be to have its own signal, so sensing signal propagated within the same fiber of the data signal, let's say. That at the end you have a Faraday rotator that need to return in order to have the phase difference that is determining there is a perturbation or not on the fiber. In this phase, just to understand how is responding the system to the environmental events, etc., we decided to use the spare fiber, so dedicated fiber, but the same in the same cable. Just the dedicated cable fiber to start the field trial. The second phase that we hope to came out in this year is just to use the same fiber where the transmission of GPON signal that is using another band that we will separate with the I2 maybe WDM channel 1 in order to coexist two different signals within the same fiber with different band channel bandwidth.
Okay. But in this final solution, the Faraday rotator is placed before the splitter or after the splitter? I mean the splitter that you have in the
it can be it depends of the use. If you want to use, but it will be at the before the splitter because they need to to power supply. On the splitter side there is no power power supply, but it depends also from the use case, because if you want to monitor the road infrastructure or bridge monitoring, you need the whole path until arriving the building basement. If you want to just to monitor only building, you can also create an environment to place this instrument, this technology under the building. Yes. We're on time.
Yes, yes. Okay, other questions? Yes.
Thanks a lot. So you showed a very large network, lot of nodes, lot of fiber. The fact of collecting all this information, having the telemetry in place, storage, it's something that is worrying you in terms of deployment, or not such a big problem?
If you use distributed acoustic sensing technology, it is a problem because they need a very huge data storage for accumulating data. But we are not using this. It is a coherent system, and the data is not too much in order to process and post-process the data. We can use the term of edge computing. If we enable this kind of system, edge computing will help to delocalize the servers in order to respond to, let's say, speed up the response of the system, because it's a prevention system. You can detect it, for example, for the earthquake detection. You can't know it one day before. It's just prevention or monitoring territory for the scope of monitoring for the scientific point of view. But delocalizing, maybe by edge computing, can help also to overcome this problem, if it will be a problem, but we don't see such a big problem. We don't accumulate too much data.
Thank you very much. Thank you. Thanks all the speakers, and see you tomorrow. I think. Tomorrow at 9 sharp. 9 sharp.